ওকে, আচ্ছা তোমরা কি গতকাল গেছিলে ডিপার্টমেন্টে?
হ্যাঁ
ইয়েস
স্যার।
স্যার।
পুলক স্যার এসেছিল নাকি? পুলক স্যারকে দেখেছো?
স্যার আমরা সিএস বিল্ডিং এ ছিলাম।
ক্যাশ বিল্ডিং এ ছিলে না? ওই যে ল্যাবে ইয়ে করেছিল ওই ল্যাবে পুলক স্যারকে দেখেছিলে কি? পুলক স্যার অ্যাকচুয়ালি পুলক স্যারের সঙ্গে আমি যোগাযোগ করতে পারিনি।
না না
আমি একটা অন্য সোর্স থেকে খবর পেলাম যে সম্ভবত পুলক স্যারের কোভিড হয়েছে, সম্ভবত, পসিবল, বাট আমি কোনটা শিওর নই, বিকজ যে সোর্স থেকে খবর পেয়েছি সেটা ভুলও হতে পারে। আমি সেই জন্যই তোমাদের জিজ্ঞেস করলাম যে তোমরা কি স্যারকে দেখেছো ফিজিক্যালি? তা যদি না হয় তাহলে তো ব্যাপারটা হয়তো হলেও হতে পারে, সেই জন্যই আর কি। যাই হোক, আচ্ছা ঠিক আছে, আমরা তাহলে শুরু করি। তোমাদের আর কোনো আপডেট কিছু আছে নাকি এই কোর্সের এর ব্যাপারে? হবে কি হবে, বা কারা কি বললেন নতুন অ্যাডমিশন
স্যার,
হবে? কিছু নেই?
এখনো নতুনরা জয়েন করেনি, অ্যাডমিশন কিছু জয়েন হয়নি। আজকে কালকে থেকে প্রবাবলি স্টার্ট হবে স্ট্রিম
ও
চেঞ্জেস, অ্যাপ্লিকেশন।
আচ্ছা আচ্ছা। আর তোমাদের বাকি যে কোর্সগুলো এই সেমিস্টারে যেগুলো রান করছে, থিওরি বলো বা প্র্যাকটিক্যাল বলো ইত্যাদি, তো সেগুলো কি সব কমপ্লিট হয়ে গেছে? সমস্ত
হ্যাঁ স্যার,
টিচার
মোরাললেস
সব কমপ্লিট?
সব কমপ্লিটেড।
মানে এখন তাহলে কি আমি একাই পড়াচ্ছি নাকি আর কেউ আছে?
না স্যার, আপনি একা।
আমি একা? বাহ, the solitary function in this respect. Okay, very good. আচ্ছা, ও একে স্যারের পার্টও কমপ্লিট হয়ে গেছে?
হ্যাঁ স্যার, একে স্যারের পার্ট মোটামুটি কমপ্লিট। স্যার বলেছেন যা ডাউট আছে সেগুলো পরে একদিন ক্লিয়ার করে দেবেন।
আচ্ছা, বাহ, ঠিক আছে, তো ভালোই হয়েছে। ঠিক আছে, ও ফাঁকা মাঠে কেউ নেই, ঠিক আছে, ওকে। আচ্ছা, আমরা স্ক্রিনটাকে শেয়ার করি। দেখতে পেলে বলবে দেখা যাচ্ছে কিনা।
হ্যাঁ স্যার,
দেখা যাচ্ছে।
দেখা যাচ্ছে।
আচ্ছা, এই স্লাইডটায় দেখো, আমি আগের দিন তোমাদের ডিসকাস করতে গিয়ে, এক মিনিট, জয়েন করছে নাকি? হ্যাঁ, এইখানে এইটা ভুল আছে। এটা এটা পয়েন্ট তোমরা খেয়াল করেছিলে? এটা আমি আগের দিন বলতে গিয়ে আমি, হ্যালো,
প্লাস
হ্যাঁ
ওটা প্লাস
মানে প্লাস হবে, এক্স্যাক্টলি। আমি পরে আমার চোখে পড়লো যে এটা তো ই টু দি পাওয়ার জে প্লাস জে ওমেগা টি আছে, মানে আইদার এটা তুমি, আর এখানে যদি সাবস্টিটিউট করতে হয় তোমাকে, তো ডেফিনেটলি এটা মাইনাস নেবে, তো তখন ওটা মাইনাস নিলে এটা ঠিক আছে। আদারওয়াইজ এটা যদি মানে ই টু দি পাওয়ার জে ওমেগা টি হয়, এটা প্লাস হবে। আমি বলার সময় খেয়াল করি, পরে আমার মনে হলো। যাই হোক, ঠিক আছে, তোমরা ধরতে পেরেছো যখন, ঠিক আছে, ওকে। এটা আমাকে একটু কারেক্ট করে নিতে হবে স্লাইডে, এখানে গন্ডগোল হয়ে গেছে, ঠিক আছে, ওকে। এটা করেছো? এই হোম হোম টাস্ক যেটা দিয়েছিলাম, এটা ক্যালকুলেট করেছো পাওয়ার? কোথায় গেল ওটা? এই যে এটা করেছো, ফাইন্ড আউট করেছো সিগন্যালের পাওয়ার এবং কম্পোনেন্টস এর পাওয়ার উইদিন দ্য ফার্স্ট নাল? %90 আসছে মোটামুটি? হ্যালো,
হ্যাঁ স্যার,
কি মানে বুঝলাম না, হ্যাঁ না না মানে করেছো না করনি না আসছে
করিনি,
না?
টাইম পাইনি।
করনি, আচ্ছা তাই বলো, ঠিক আছে, তা করবে এটা, ঠিক আছে, এই
হ্যাঁ
প্রবলেমটা
স্যার,
করবে কিন্তু,
হ্যাঁ স্যার।
ঠিক আছে। এটা তো আগের দিন ডিসকাস করা হয়েছে, এগুলো তো ঠিক আছে। হ্যাঁ, আমরা আজকে সম্ভবত যে পয়েন্টটা নিয়ে ডিসকাস করার কথা, সেটা হচ্ছে তোমার রিগার্ডিং এক্সিস্টেন্স অফ ফুরিয়ার সিরিজ, তাই তো? তো বিফোর উই গো ফর ডিসকাসিং দ্য ডিরিক্লেটস কন্ডিশন, যাই বলো উচ্চারণ করো, so we have to first discuss some points that is relevant in this context, because before Dirichlet came, there was some condition regarding the existence of Fourier series. There were some conditions, okay? And to discuss the thing, let me start with, like, that it is a matter of fact. I mean, already it has been established, discussed in the class, that you also know that we can actually express, or better to say, we can expand any given periodic function in a Fourier series. We know that. So far, whatever we have discussed, from that, we know that. So that means we can write that xt, if it is a periodic function, any periodic function, it can be expanded, or it can be decomposed, or can be written, whatever you say. But first, before that, just let me write the property of what I want to mean by the periodic function, t plus t naught. And you know what is t naught? Is the minimum time, that, or the smallest time that satisfies the condition of periodicity. Now, it can be decomposed or expanded into Fourier series. That means superpositions or the summation of ideally infinite number of sinusoids. So which can be written, okay, the exponential form I'm writing, which can be written like k equals to minus infinity to plus infinity ak. আমি এই নোটেশনটা ইউজ করছি, ডিএনটা ইউজ করছি না, একই ব্যাপার, নোটেশনটা কোনো ম্যাটার করছে না, কনসেপ্টটা ম্যাটার করছে। যে কে ছিল কে ওমেগা নট টি, এটা ছিল, ঠিক আছে। উই ক্যান এক্সপ্রেস লাইক দিস, where ak, how to find out ak, you know that ak equals to what, 1 by t naught, this t naught, okay, t naught integration over t naught, one time period, xt, if it is, you know, it's a synthesis equation, here it will be plus the exponent, and in the analysis equation it would be e to the power minus j k omega naught t dt. It's the integration over time, but ak is this. So these two are the equation. These two equations, with the help of these two equations, we can do anything. We can do anything in the, as far as the Fourier series is concerned. That means we can, given a periodic signal, we can find out the AKs. That means from the input to output we can go. Or given all the AKs, we can construct, or rather reconstruct the periodic signal. That means from the output to input. So both the synthesis and analysis is possible, and this set of equations, you know, they actually gives you the complete information regarding the Fourier series. That is why this is called the complete statement of Fourier series. Okay? And বারবার এই যে জায়গাটা বারবার বলছি, নিশ্চয়ই বুঝতে পারছো কেন বলছি, কোথাও কিছু ব্যাপার এখানে আছে, ঠিক আছে। If you are intelligent enough, then you can understand. Okay, now here in this context, basically we are trying to discuss about the existence of Fourier series. Okay, the Fourier series and its existence today. Now, as I mentioned, before Dirichlet came, some conditions were already there. Some conditions were already established. Okay, already there. That was in existence. But when actually the concept of Fourier series came, the two possible, or better to say, two obvious questions that came along that Fourier series, the concept of Fourier series, are like these two are the basically very, you know, what I say, kind of very uncomfortable or irritating or annoying questions. That is the very obvious questions. That is obviously that comes in association with the Fourier series or the concept of Fourier series. But these two questions can put anyone in a very awkward situation. At least in those days, that was true. That was the fact at that time. And what were those two questions that were being asked at that time? The first, regarding the existence of Fourier series. The first question is very obvious, that even this question should actually, you should ask yourself, okay, that these two possible questions that should come in your mind also. If you, the first time, if you are reading the Fourier series or learning the Fourier series things. But the question is, if you just look at these two equations, this analysis and the synthesis equation very carefully, the obvious question that should come in your mind is that if suppose there are actually, ideally, there are an infinite number of AKs, na? So if suppose one or more than one AKs blow up That means become unbounded, go to infinity. What I'm trying to say. Then the question is whether the Fourier series will exist or not. Whether the Fourier series will exist or not. That is the question. Fourier series exist করবে কি করবে না, that is the question. ঠিক আছে, it is the obvious question এখান থেকে আসতে পারে. Second question was that you can say, suppose if you consider that none of the AKs become infinite, that means none of the AKs suppose blows up, everything is well behaved, then whether this summation converges to, because it's the synthesis equation, whether this summation converges to this value xt. These are the two possible questions. These two questions are very annoying, very uncomfortable, obviously, because in those days it was very difficult to answer this question, and people were just searching for the possible answer, suitable answers. Okay, the last part, what I'm trying to say, it is even important, because if suppose the answer of the first question is okay, none of the AKs blow up, all the AKs are well behaved, all the coefficients have a finite value. But the point is, even though all the coefficients, all the AKs are finite, well behaved, none blows up, even though at that condition, is it guaranteed? Can you certainly say that this summation converges to xt? That means, in very simple words, you can say, whether if you just sum up all these terms, okay, you will exactly replicate xt for all at all times, for, or you can say for all values of t concerned. Actually, it's a periodic, so that means from minus infinity to plus infinity, everywhere. Is it possible? Is it guaranteed? These are the two questions. That means here, in case of the second one, I'm basically discussing both of them, but I'm trying to elaborate the second part a bit. Actually, what I'm trying to mean that, suppose, let me start with suppose you go for the summation. It's a finite summation. Suppose k equals to minus n to plus n. Okay, ak e to the power j k omega naught t. Fine, we just start with this summation, and gradually we start increasing the value of n. First with a smaller value of n, finite, and then start increasing the value of n. And as if n tends to infinity, when n is allowed to go to infinity, we are taking a very, very large value of n. Just consider like that. Now, that means we can write, this implies we can write one after another, we actually keep on adding the terms, one after another. N increases means we are the terms we are adding, actually. Okay. So that means, suppose mathematically this can be written the same thing, that n tends to infinity or n approaches infinity, is a very, very large number. So we can write like this: limit n tends to infinity, summation k equals to minus n to plus n, ak e to the power j k omega naught t. Okay, like this. So the question is whether this actually converges to xt. This is the question. Whether this converges to xt. It may or may not converge. Is there any guarantee that it will always converge? No, actually not. It may converge, it may not converge. It may converge, it may not converge. Now, the point is, even if, this is the important point, I'm stressing it again, even if none of the AKs, all the AKs are having finite values, all the AKs concerned, finite value. Every AK is a well-behaved AK. But still, they may converge, may not converge. There is no guarantee. Or the question, in the form of question, if you ask that, is there any guarantee? You can certainly say yes or no. This is the point I'm trying to emphasize here. Now the answers of these questions, actually people have tried, as I mentioned, And whatever we are discussing here at this point, everything was valid before Dirichlet came. Please note that point. Because when Dirichlet came, after that something changes. Okay, story will change a bit. But here, whatever we are discussing at this particular point, that actually indicates that where before Dirichlet came. But the concept of Fourier concept was there. The Fourier analysis, synthesis, all those concepts were already there. Concept was there already. Okay. So obvious questions, that is the obvious questions, that is very relevant questions, but these questions are very irritating because the answer is very difficult actually to find out or to get. So that is why, but people have tried. People have tried to come up with the different types of answer, different types of conditions, okay, to check regarding this existence, okay, when it will exist, under what condition, if this condition is violated, whether it will exist or not, and so on and so forth. There are lots. If you survey the literature at those times, it's very difficult to get all the literature, but some of the literature are there in our university also, in the university library. But anyway, so if you search, actually there's a history kind of, that becomes completely history, that's become a story kind of. So if you search those, and one bottom line, one single line you can draw from there, that is, people have tried a lot, actually did tried a lot, really a lot, but every time they came up with a sufficient condition. Sufficient condition. There is no, they failed to find out any condition which is necessary as well as sufficient. Are you getting the point? All the answers of these two questions are only in terms of the sufficiency, not necessary and sufficient both as a whole. Means what I'm trying to say, I'm giving an example in this context. In this class, we have discussed, probably you can remember, we have discussed about the condition that a LTI system will be causal. That means the causality, condition of causality. We have discussed. We have also discussed the condition of an LTI system to be Bibot stable. That means that's Bibot stability condition. We have discussed, and we have discussed the theoretical aspects, we have derived the mathematical background behind that. We have done all this thing, and we have also dealt with some examples. Now, probably you can remember the statement I made at the time, and I told you sometimes in your question paper this become quote unquote the statement and then explain it or illustrate it or substantiate it, kind of. This kind of questions are very obvious, you can expect. So probably suppose if I cite the example of the causality of an LTI system, you probably remember that an LTI system will be causal if and only if, just statement, please note, if and only if the impulse response is 0 for negative time index. If it is a discrete time, or if it is a continuous time, then for negative values of time or negative values of n, whatever you say. It doesn't matter whether it's a discrete or continuous, but that's the concept. So this condition, if this condition is satisfied, it is guaranteed. It is guaranteed the system will be causal. And if it is not, it is also guaranteed the system will not be causal. So that is why it is necessary and sufficient both as a whole. Necessary and sufficient both as a whole. Similarly, if I cite the second example, what we discussed in our class, that is the condition of stability. That means Bibot stability, of course. Bibot stability of an LTI system. And there also, we again, after doing the mathematical analysis, we probably can remember gave a statement that your LTI system, okay, will be stable. Again, stable means Bibot stability. It is implied. I'm not saying again and again. So if your impulse response, if it is a discrete time, if your impulse response is absolutely summable, or if it is a continuous time case, then your impulse response will be absolutely integral. Now, you can remember that this condition is not only sufficient but also necessary to ensure the stability of the system. That means, if this condition is satisfied, this is guaranteed, you can blindly say the system is Bibot stable. And if it is not, you can blindly say this system is unstable. Be more unstable. So these like this, I can also cite another example, like the example of your linearity of a system. In case of the linearity, you know, there are basically two sub-conditions. Okay, one is the homogeneity, and another is the superposition. Now, if a system is homogeneous, it is actually obeying a superposition formula, a rule, a law, then is it guaranteed that the system is linear? No, not at all. Because if it actually obeys the superposition rule or relation or formula or condition, whatever, but it may be linear, may not be linear. But if a system, that is, if it's zero input leads to zero output, that means if it follows the the homogeneity principle, then you can say it is your linear. But if it is not, then you just reject. There is no need to test further. So that means these two, the superposition and the homogeneity, are respectively the sufficient and the necessary conditions for the system to be linear. So these are the like few examples already you did. You have the past experience in dealing with such necessary sufficient conditions like terms, and in the context I have already mentioned. Here also the same thing I'm trying to discuss, that the conditions that people came up with different times. Again, different time is before DD eclipse. Okay, particularly I should mention that. So, but the point is, everything was kind of, the bottom line what you can draw. As I mentioned, if you survey the literature, if you go and study the history, the bottom line that you can draw is that, again, all these in terms of the sufficiency. Not necessary and sufficient condition. If and only if you cannot say. Yes, if it satisfied, yes, that can be, that Fourier series maybe exist, but there is no guarantee. If it fails, then also the Fourier series may also exist, something like that. Okay, so that is why this is just a sufficient condition. So now, if you just look at the particular, now I just want to go by question by question. The first question was like that if one or more AK blow up or go to infinity, whether the Fourier series exists or not. That was the question. Now, actually, if the energy, let me discuss this thing first. Suppose the energy of a signal, of a periodic signal, energy of a periodic signal, don't get confused, because when I am talking about the energy of a periodic signal, it is implied that I am trying to find out the energy over single time period. That is mod xt whole square dt. Now, if the energy of this periodic signal, that means this is less than infinity, that is, energy is finite over a single time period. Okay, energy is finite. Then the coefficient, because the first question was whether AKs will blow up or not, or something like that. You have to check for the existence of the Fourier series. Then it is guaranteed. Then you can say that the coefficients will be finite. Coefficient means all the AKs will give you finite value. That means none of the AKs will blow up if the energy of this signal of the periodic signal over a complete time period is finite. That is the point. Now, as I mentioned, this is one of the conditions for the existence of the Fourier series, but that is only sufficient condition. That means if this condition is violated, there is a guarantee that AKs will blow up or not, or something like that. But if it is followed, then it is guaranteed that AKs will not blow up. Then coefficients will be finite for the existence of the Fourier series. Now, you can mathematically prove it, that the statement I gave just now, that if the integration of the squared magnitude squared of the xt, where xt is a periodic signal, that is the energy of the xt over a single time period, if it is finite, if it gives you a finite value, then all the AKs will be finite. All the coefficients will be finite. This can be proved mathematically. But again, here we are not doing any mathematics, so I'm just skipping that part. There is no need to unnecessarily discuss that thing. If you're interested, you can follow any book. From that, there you will get it. But that is a condition I have mentioned. That is important in this as an answer of this first question. Now, as answer of the second question, you can say that means the second question was that even if none of the AKs blow up, all the AKs are finite, that means whether the series converges to the xt for all values of t or something like that. That was the second question. Now, here, suppose in this case, in the second case, suppose if, as I mentioned, even if the coefficients are bounded, I mean none of the AKs blow up, none of the AKs actually blows up, then how do I know that, as I mentioned here, that this summation converges to this? How do you know? That is a question here actually written. I'm not repeating it. It is written. How do you know that? Now the point is, actually there is no answer to this. It is an unanswerable question. You cannot give any answer. Okay, we don't know. We cannot give any mathematical proof or something like that. We cannot go. Or I should correct my statement a bit, that there is no straightforward or direct answer to this question. But there is an indirect, answer to this question, which is not very direct, not straightforward, but there is an indirect answer to this question. The question indirect, why I'm saying indirect? Because the question was whether it converges to, the summation converges to xt, whether the right hand side converges to the left hand side for all values of t. That was the question. That means in each and every value, for each and every value of t, whether this side and that side will be identical equal. That is the question. But again, as I mentioned, you can't give any direct answer, and mathematical proof is also not possible. But here mathematical proof is possible for the first case. Now the point is, that is why people came up with a indirect means to kind of tackle this situation, you can say. And what is that indirect means? The indirect means or indirect way means actually it is in the sense of the answer I will give, but that is in the sense of energy. In the sense of energy sense. It is called the energy sense. Energy sense is what? Let me elaborate the thing a bit. You already have introduced that, but still in this context I'm again repeating. The meaning is that the energy of the error function should be zero. That is the statement. You know that already. It's the energy of the error function should be zero. That means suppose this signal, this side and that side is not identical for each and every value of t. Suppose, for example, it doesn't matter. So what we will do? We basically want to find out the error. Now, what is the error? You know how to define error. Already we have introduced this thing. The error is something like this. ET. You can define ET. It is a notation of definition. ET is like xt. Difference between this and this, left hand side and right hand side. Even though they are not identical for all values, when all values of t I likhte parchi na. Okay, I cannot write that. So xt minus summation. Okay, I'm just writing over infinite number of terms. Okay, so let me write it like k equals to minus infinity to plus infinity, or in this way also you can write, doesn't matter in this context. So ak e to the power j k omega naught t. Okay, and this, you know, what is this? This is basically the given periodic function, this one, having this property. And this is basically the total series. It is, please note, this is an infinite series, not finite. It is infinite. Still, we are trying to find out the difference. Now, what is the condition? The condition that we are imposing, that is the indirect condition. The condition we are imposing, that This is an error signal, ET. This is an error signal. And what we have told that the statement we made that the energy of this error signal will be 0 over a time period. Energy of this error signal. That means this is an error signal. So energy of the error signal means, mod of ET. Its square. Integration over, as I mentioned, on one period. And integration, that should tends to 0. This is the only sense of convergence that can be applied. Otherwise, there is no sense of convergence. Because the question was whether it will converge. That's why I told you there is a straightforward or direct answer. Convergence implies what? For each and every value of t, both the sides will be identical. That is the meaning. If at any point it is not identical, then that means it not converges to that. Right hand side doesn't converge to the left hand side for that value of t. Suppose that is a very straightforward, simple thing that we can understand. But here the things is not simple that sense, or straightforward that sense, better to say. It is a bit indirect way we are saying, okay, the value may be different. The value may be different, doesn't matter. That means there will be an error signal introduced. The error may be positive, negative, doesn't matter. Whatever the error will be, we will just take the error, we will just take a mod of that, we will square it and integrate over the time period, one time period. And if it converges to 0, that means the area under the squared value of the error signal is very, very, very small. So small that it can be approximated like 0, almost negligible kind of. Then we can say it converges to the right hand side, converges to the left hand side. That means the series converges to the, in general, you can say the series converges to the original periodic signal. This is the point. So once we are able to establish that all the AKs are finite, so then our task is that first to establish whether all the AKs are finite or not. For that, this is the condition. Again, that is also sufficient. Whatever condition we are talking about, all are sufficient, just to remember. So all the AKs are finite or not from this. Suppose we have established, yes, all the AKs are finite for that given periodic function. Now our next task is to expand the function into Fourier series like this. To expand this like this. Now, again, as I mentioned, please note, it doesn't mean that for each and every value of t, in the left hand side and right hand side, for each and every value of t, the left hand side and the right hand side will be exactly identical. That means exactly give you the same value. Here, suppose you put the value of t equals to 0, here also put the value of t equals to 0. Suppose, for example, whether this will be exactly equals to this, we don't know. That we cannot guarantee. That may be, may not be. Okay, but that doesn't mean that this will not convert as a whole. As a whole, this will not convert, the summation will not converge to the xt, for the original periodic signal. But again, as I mentioned, value-wise, for each and every value of t or time, they may not be identical. The two functions may not be identical. The left hand side and the right hand side may not be identical. But that doesn't mean that identical means there may be difference. Okay, that's the error signal. There may be some difference. Okay, it's like etc. etc. But the point is, in energy sense, they may convert. This may converge to this. In energy sense, that means even though both the sides are not identical for a particular value or more than one values of time, that means different points of time may not be identical. There may be some difference between the two. And if there is a difference, that means that is the error signal. If there is a difference, you just take the difference. You just magnitude square them. Take difference. Take the magnitude. That means you take the mod. The mod, and then square them, and then integrate. Integrate over one complete time period. And if that tends to 0, then you can say, okay, we got the answer. Yes, it will converge. But again, as I mentioned, this is a not very straightforward or direct way to give the answer or put the conditions for the existence. So it is in some sense a restricted, or people say it's in existence in a restricted sense. People call it the restricted sense, existence of Fourier series in a restricted sense. That means it does exist, but it does not ensure that at point or at every point, xt will be identical to the Fourier series. This will be identical to this, or this will be identical to this for each and every point. So that is why it is a restricted sense. The series exists, or this converges to this, and that restricted sense is the energy. Energy of what? Energy of the error signal over a time period. If that converges to zero, then in that sense we can say the series exists. So sometimes people also call it that, obviously you can understand it's a very sufficient condition, and as it is not a very straightaway, direct, complete kind of statement, so you can say it is an incomplete condition also. The condition of existence for the existence of the Fourier series, it's kind of an incomplete condition. It actually doesn't give you the complete picture or the full picture or the actual picture, better to say. Suppose the analogy I can give in this context. The analogy in the present days, you probably you have noticed different types of reality shows in different channels, whether it's a Bengali, Hindi, or etc. In reality shows, sometimes suppose a singing competition or a dancing competition or something like that. Now the performers, when they perform, sometimes the performance is very good, excellent performance kind of. Okay, so the judges actually appreciate very much, and then fully satisfied. Okay? Fully satisfied. All the suppose it's a singing competition, and all the conditions, all the parameters to evaluate, they're fully followed, and judges can put the check mark or tick mark for all the conditions are satisfied to become a good performer at this particular point, at this stage, on this stage. So satisfied, fine, fully okay. It's called a complete performance. But sometimes what happens? Sometimes the performance is kind of okay performance. Okay, the very best performance. Some of the parameters satisfied, some of the conditions satisfied, some they can put a check, but somewhere they cannot put the cross. But okay, just considering other situations like the performance of the rest of the performers, and suppose some guest judges come to honor him or her, or something like that, or to respect or to give people's choice, maybe there, some kind of emotional aspect maybe there, etc., etc. So considering all those, they go, okay, let us consider another. Okay, you are promoted to the next round. You are eligible for the next round. Sometimes this happens in the reality shows. So it is something like that. Okay, the conditions are not fully satisfied. The complete performance, some restricted sense. Okay, we are allowing the performer to go for the next round. We are not eliminating him or her. So it is a kind of that. Okay. Now with this, actually, it is a. I think I have already discussed in the slide. This is already there in the slide. Let me check it. Yes, look at this note. We have already touched these points. The error energy can approach zero even though it is error signal that is defined like this. Look at this. Okay. It is a general concept. It's a general concept that comes from the the orthogonality set of real signal, but not particularly in the context of Fourier series. But the story is same. The philosophy is same. So error signal, and then the difference between the two sides, which is the error, is non-zero at some isolated instance. Please note the language. That's why I mentioned. For each and every value of t, that may not be same. That means there may be error. The reason is that if et is non-zero at such instant, the area under it is still zero. That means the energy, area under ET means what? Area under E square T means what? That means H square is basically the energy. So energy of the error signal is 0, even though ET is not 0. It is not 0 kind of, because if it is 0, then this is identically equals to this. So there is no point. This is very straightforward. That is okay. Fine. Perfect. But ET is non-zero means this is not equals to this. Either this is larger than this or this is larger than this, something like that. So there is some non-zero value of ET. At some point, some values of T, maybe that may be one for one particular value, maybe more than one values of T. But if you take the square of this and integrate over a time period, say for if it's a periodic signal, or in general, here it is they are saying in general square. So if you do it, and that is an interval they have taken from T1 to Tt, if you just do that on that interval concerned, then it will actually tends to 0. That is the point of convergence. That is the point of convergence. That's why I mentioned it is already there in the slide. I've already introduced. And the example, this example we cited with the help of this particular picture or this example, we have cited that there is an error. There is an error. There is an error. There is an error here, here, here. Okay, there are different errors in different points. The value wise they are not same, but it may be that energy wise, energy of the error signal may approach 0, and in that sense, actually, this red colored signal, which is a superimposed version of many sinusoids, okay, harmonically related sinusoids, may converge to this blue signal, which is the actual XT. That is the point. Okay, so
স্যার
বলো।
হ্যাঁ স্যার, আমার একটা প্রশ্ন আছে। আমি বলতে চাইছি যেটা, যে কোনো একটা ফাংশনের ফুরিয়ার সিরিজ মানে হলো তার আইগেন স্টেট এবং আইগেন ভ্যালুর বিভিন্ন কম্বিনেশন করে তাকে লেখা।
ওকে,
তার মানে স্যার, যে কোনো একটা ফাংশন নিন, তার ফাংশনের প্রথম কয়েকটা আইগেন স্টেট মানে e⁻1 kt 2 kt 3 kt কয়েকটা আওয়ার পরেই তার 90% আইগেন ভ্যালু দিয়ে তাকে ফিল আপ করে দেওয়া হয়। তারপরে যত যাওয়া হয় তারপরে ওই 10%টাকে ওটাকে কভার করার জন্য আলাদা আইগেন ভ্যালু নেওয়া হয়, মানে আলাদা আইগেন স্টেট থেকে। এটা কি করে ইনফিনিটি হতে পারে? মানে যে কোনো একটা রিয়েল ফাংশন, মানে যে কোনো একটা ফাংশন নিন, মানে যে কোনো একটা যদি ফাংশন নিই, তার আইগেন ভ্যালু গুলো 100 কি মানে 200 খানার পরেও হয়তো 90% কভার হয়ে যাবে। সেটা একটা টাইম সাইকেল নয়, আমি যদি n খানা টাইম সাইকেল নিই তখনও। তাহলে আমি এটা বুঝতে পারছি না, তাহলে ইনফিনিটি কি করে হয়? সামেশন যেটা বলছি আমরা, যে
সামেশন যেটা ইনফিনিটি বলতে, দেখো যে পিরিয়ডিক সিগন্যালটা তোমাকে দেওয়া থাকবে সেই পিরিয়ডিক সিগন্যালটা তো যে কোনো ফর্মের হতে পারে। The periodic signal may be of any form. ব্যাপারটা বোঝার চেষ্টা করো। অ্যাকচুয়াল বেসিক, জাস্ট গো ব্যাক টু দ্য রুট। রুটে তোমাকে কি বল, যখন ফুরিয়ার সিরিজ ইন্ট্রোডিউসড হয়েছিল তখন তোমাকে বলা হয়েছিল এনি পিরিয়ডিক সিগন্যাল ক্যান বি রিপ্রেজেন্টেড অ্যাজ এ সামেশন অফ ইনফাইনাইট সাইনোসয়েডস ইন জেনারেল। ব্যাপারটা বোঝো। এনি পিরিয়ডিক সিগন্যাল, এনি পিরিয়ডিক সিগন্যাল, পিরিয়ডিক বলেছে, আর কিন্তু কিছু বলা নেই। পিরিয়ডিক ছাড়া আর কোনো কথা বলা নেই সেখানে। ইভেন ফুরিয়ারও সেই কথাটা বলেনি। ফুরিয়ার শুধু বলেছেন যে এনি পিরিয়ডিক সিগন্যাল ক্যান বি রিপ্রেজেন্টেড লাইক এ সামেশন অফ ইনফাইনাইট সাইনোসয়েডস। তুমি যেটা বলছো যে সেটা হচ্ছে আইগেন ফাংশন, আইগেন ভ্যালুর যে কনসেপ্টটা, সেটা হচ্ছে ইফ ইউ হ্যাভ দ্য সাইন, উই ডোন্ট হ্যাভ এনি প্রবলেম উইথ দ্য সাইনোসয়েড, উইথ দ্য কম্পোনেন্টস। We may have the problem with the coefficient. If the periodic signal, it may be periodic, but it behave in a odd manner or different manner. Is there any guarantee that for any kind of periodic signal you can decompose it in a with the well behaved components? Is it guaranteed? এটাই তো প্রশ্ন।
ঠিক আছে স্যার,
বুঝতে পেরেছো? আমি দেখাচ্ছি, আমার শেষ হয়নি, আমি এক্সাম্পল দেখাবো, চিন্তা নেই, ঠিক আছে? ওকে, আচ্ছা, আমরা কি বলছিলাম? এই এক্সাম্পলটা দিলাম। আচ্ছা, হ্যাঁ, তো এই এক্সাম্পলটা আমরা আবার আসবো, ঠিক আছে? এখানে আমি আবার আসছি, অনেকগুলো স্লাইড আপনি এদিক ওদিক করতে হচ্ছে আমাকে, বাট এটা অ্যাকচুয়ালি এর সঙ্গে রিলেটেড বলেই বলছি, আর কিছু না। আচ্ছা, আমরা ছিলাম কোথায় বলো তো? অ্যাকচুয়ালি কোন জায়গাটা বলছিলাম বলো তো? এটা আমরা ডিরেক্ট লিস্ট কন্ডিশনে আসবো তো? ওকে ওকে ওকে, মনে পড়েছে। হ্যাঁ, আমি তো এই স্লাইডটা বলছিলাম। ওকে, সো দ্য পয়েন্ট ইজ, এটা তো ডিসকাশন হলো। এবারে দেখো, এইবারে পয়েন্টটা আছে, দেখো আমি এতক্ষণ ধরে যেটা ডিসকাস করছিলাম দ্যাট ওয়াজ বিফোর ডিরিক্লিটস কেম, আমি যেটা প্রথম থেকে এমফাসাইজ করে আসছি। Now the point is, in order to solve this problem, as হয় না যে different times, it's an open problem, research problem. ধর তোমরা যখন রিসার্চ করবে, যারা রিসার্চে ইন্টারেস্টেড, যারা ভবিষ্যতে রিসার্চ করবে, দেখবে তোমরা যে ধর একটা প্রবলেম, ধর প্রবলেমটা তুমি যখন নিলে, when you take up that problem, probably it is already 10 years 20 years old. It was a very challenging problem, but till date there is no such a very good or better or very efficient solution. Okay, so তোমার কাছে মনে হলো, it may seem to you that okay, I may take up the problem even though it's a bit older. Okay, so I will try to solve it and want to come up with a very efficient solution, efficient kind of solution, in a very compact form. That different mathematical model people develop different times. In the previous days, the people developed the model for the MOSFET, suppose. Those models were not very compact, not very efficient, not very, and when we will program it, when you will computationally efficient, better to say, I'm trying to say, may not be. It takes a very large memory, computational time, etc. But in today, people are doing different types of different types of algorithms that are applying to reduce the model in a very efficient, or to express the model in a very efficient manner, so that computationally they are efficient, memory saving will be there, etc. The time will be very less, time requirement will be very less. Now, these are the efficiency I'm talking. So, different time people came, they come up with a different solution, different types of solution. Maybe the problem may be same, but the type of the solution or the approach or the methodologies may be different. Like the same thing happened here also, that this gentleman, yes, this gentleman, Dirichlet. So Dirichlet, his full name was, I suppose, Peter Gustav Dirichlet. Okay, so he was a German mathematician. Fourier was a French mathematician, though he was like a versatile genius. He has different contribution in different areas, different disciplines. We already discussed that. But anyway, in our case, we are only interested with his efficiency in mathematics, actually, because the contribution, it is basically his contribution we are learning. So that comes from the mathematics. That is based on mathematics. So anyway, so we know Fourier from his contribution in mathematics. Like Dirichlet was also a mathematician, but he was from Germany. He came up and took these two annoying questions. Okay, he told that okay, no problem, I am taking it as a challenge and want to come up with a better solution, a better approach to solve this. Okay, but this problem is, after a rigorous research, when everything came, the conclusion that can only be made is that all the conditions are still sufficient. That is sad, but that is a fact. So Dirichlet's condition, even though Dirichlet is very popular, in the context of Fourier series, we all have heard the name of Dirichlet and his conditions. But the point is, all these conditions are again sufficient conditions. They are not both necessary and sufficient. It is the problem. But though Dirichlet did a very rigorous research on this, but again, there is no. But in general, people actually, the Dirichlet's condition can be categorized or divided into mainly three parts, or better to say, Dirichlet actually gave three conditions broadly. Okay, and that together means, while I am saying it's a sufficient, it's together it is a sufficient condition for the existence of the Fourier series. But again, all these conditions, the three conditions that is written over here in the slide, these three conditions can be proved mathematically. Again, I'm telling you, that is the beauty. Three conditions can be proved mathematically, but again, that is beyond the scope of this class. We are not the mathematician, so we are just skipping it. So we are just straightforward entering into their physical interpretations and the discussion related to that, taking it some examples. Like, say, for example, the first condition or the first case. The first case, what is written? For the existence, for the series to exist, the signal should be absolutely integrable. For the series to exist, the signal, এই তোমরা স্লাইডটা দেখতে পাচ্ছ তো? মানে আমি অবশ্য মোডে দিইনি, স্লাইড শো মোডে দিইনি।
হ্যাঁ স্যার, হ্যাঁ স্যার।
For the series to exist, the signal should be absolutely integrable. That is the first condition, first Dirichlet's condition. আচ্ছা, এখানে একটা কথা বলি, এই যে ফার্স্ট, সেকেন্ড, থার্ড, এটা না ঠিক আরবিট্রারি নয়, এটা মানে ব্যাপারটা হচ্ছে ইট ইজ ডিউ টু দ্য হিস্ট্রি, ইটস দ্য হিস্টোরিক্যাল, মানে কি বলবো আসবে। এখানে মানে তুমি আর্গু করতেই পারো যে স্যার আমি 2টা যদি 3-এ বলি, 3টা যদি 2-এ বলি, কি অসুবিধা? দেখো সেই কনটেক্সটে আবারও একই কথাই বলবো যে ওইভাবে নাকি কাউন্টার করাটা হয় না, এটা জাস্ট একটা চলে আসছে প্রচলিত কনভেনশনাল। হ্যাঁ, যে কোনো স্ট্যান্ডার্ড বুকস তুমি যদি খোলো, as a first condition of the Dirichlet's first condition of the first case বললে এটাই বোঝাবে যেটা লেখা আছে, সেকেন্ড বললেও যেটা লেখা আছে সেটাই বোঝাবে it is related to the maximum minimum, and the third বললে obviously it is related to the discontinuity। এইভাবেই বলা হয়, দিস ইজ দ্য ওয়ে ইট মানে হ্যাভ বিন চলে আসছে, হ্যাঁ, মানে ফ্রম দ্য পাস্ট টিল টুডে। সো এখানে না ওই ইঞ্জিনিয়ারিংটা করা যায় না, যতই যাই বলো না, ঠিক আছে? আর্গুমেন্ট, কাউন্টার আর্গুমেন্ট এখানে চলে না। সো এই কনটেক্সটে কিন্তু কোনো করো না কখনো কারোর সঙ্গে, কোথাও আর্গুমেন্টে যেও না কোনো জায়গায়, ইভেন নট ইভেন দ্য ইন্টারভিউ বোর্ড। তোমাকে যদি কোথাও বলে যে হোয়াট ইজ দ্য সেকেন্ড Dirichlet's condition for the existence of Fourier series, that implies this one. What is the third Dirichlet's condition? This one. সেখানে তুমি বললে এটা, সে বললো না এটা, বা ইত্যাদি, যে এটা কাউন্টার আর্গুমেন্ট করে এটা, সেরকম করবে না, আমি বলে দিচ্ছি, ঠিক আছে? সব জায়গায় এগুলো চলে না, ওকে? আচ্ছা, যাই হোক, এবার যে পয়েন্টটা আমি বলতে চাইছি সেটা হচ্ছে যে Dirichlet প্রথমে এসে বললেন, Dirichlet কি বললেন, বা Dirichlet কটা 2-3টে খুব সুন্দর জিনিস করেছেন, কিছু চেঞ্জেস করেছেন, কিন্তু ভালো করে লক্ষ্য করবে। ওই জন্যই আমি বিফোর Dirichlet আমি একটু তার হিস্ট্রিটা বললাম যে তার আগে কি ছিল। Dirichlet যেটা বললেন যে দেখো, why we are only talking in terms of the energy, because before that the condition was if the energy of the signal is finite over a single time period or one time period, then all the AKs will exist, then all the AKs will be finite. Now the point is, Dirichlet says, what about the absolute integrability of the function? Why we are only bothering about the energy? Why we are talking about the square integrability? Why not the absolute integrability? সেটা উনি ম্যাথমেটিক্যালি প্রুভ করেছেন, কিন্তু ওই জন্য বললাম না, প্রুফ গুলো সব এগুলো আছে, ম্যাথমেটিক্যাল প্রুফ, কিন্তু সেগুলো বিয়ন্ড দ্য স্কোপ, আমরা এগুলো করবো না। সো অ্যাকর্ডিং টু হিম, এই যে স্টেটমেন্টটা লেখা আছে দেখো ভালো, অ্যাকর্ডিং টু হিম অ্যাকচুয়ালি, লিখতে গেলে কি করতে হবে, পেন নিতে হবে, তাই তো? So according to him, actually what is he actually said or tried to say at that time, basically integration over a single time period mod xt dt, তাই তো? absolute integrability মানে এটাই বোঝে, that must be finite, that means that should be less than infinity. If this is less than infinity, then it is guaranteed that all the AKs will be finite. Why we should go for finding out the energy and integrating over that over a single time period? There is no need. Only absolute integrability is sufficient, because if it will be finite, this signal, the absolute value of the signal over a single time period will be finite if the energy of the signal over the complete time period is finite. So there is no need to go for the energy. আমি এনার্জি দিকে যাবো কেন? এটা ম্যাথমেটিক্যালি প্রুভ করেছে, ঠিক আছে? এটা আমার কথা নয় কিন্তু, ঠিক আছে? সো এই আবার বললাম, তো যাই হোক, আমাদের স্টেটমেন্টটা নিয়ে ইন্টারেস্টেড আমরা। সো এইটা হচ্ছে সেই কন্ডিশন, দ্যাট ইজ ইন্টিগ্রেশন ওভার এ কমপ্লিট টাইম পিরিয়ড of the modulus of the signal or the magnitude of the signal. If it is less than infinity, then it's okay, all the AKs will be finite. That is the problem. এইবার এইটার এগেইনস্ট তোমরা যেটা বলছিলে না যে স্যার যদি এরকম না হয় বা অন্যরকম কিছু হয় তাহলে কি হবে ইত্যাদি ইত্যাদি, দেখো এই এক্সাম্পলটা দেখো, look at this example. এই এক্সাম্পলে একটা জিনিস লক্ষ্য করো, এখানে বেসিক্যালি যে ফাংশনটা আছে সেই ফাংশনটা কি? ফাংশনটা হচ্ছে এই যে কন্ডিশনটা দেওয়া আছে, যেটা আমি লিখলাম এক্ষুনি সেটা এখানে দেওয়া আছে, এই যে দিস ওয়ান, ঠিক আছে? তাহলে এই কেসগুলো সব ফাইনাইট হবে, ওকে? এবারে যে এই ফাংশনটা, যে ফাংশনটা এখানে দেওয়া আছে, দিস এ পিরিয়ডিক সিগন্যাল, বাট অ্যাকচুয়ালি the variation the law of variation for the signal is 1 by t, xt equals to 1 by t, and that is within 0 to 1. So that means the period is 0 to 1. The period is 0 to 1, and this signal is made to repeat, forced to repeat after 1 unit of time, and thus it becomes periodic. এবার তোমাদের একটা অলরেডি আমি অ্যাসাইনমেন্ট দিয়েছি, তার মানে একটা সিঙ্গেল অ্যাপিরিয়ডিক ফাংশন আছে বা তার একটা পার্ট, যে আমি কি করে এরকম ভাবে তাকে পিরিয়ডিক বানাবো, হোয়াট ম্যাথমেটিক্যাল অপারেশন আই হ্যাভ টু ডু। ঠিক আছে, এগেইন ভেরি ইম্পর্টেন্ট কোশ্চেন ফর দ্য ইন্টারভিউ। আচ্ছা, এটা আমি অলরেডি তোমাদের দিয়েছি। সো করেছো, কেউ পেরেছো, বলতে পারবে, ভেবেছো কি? This is the application of convolution রে বাবা, this is an application of convolution. একটা সিগন্যালকে কি করলে সেই সিগন্যালটাই রিপিটেড হয়, কি করলে, what operation you do on a signal to get itself?
Convolute with delta function.
Convolute with delta function. Now if you shift that delta function, so what would happen? কনভলিউশনের প্রপার্টির মধ্যে বলেছিলাম দুটো ফাংশনের মধ্যে you are convolving two functions. If one of them is shifted, then what would happen? The convolved signal will be shifted by the same amount, isn't it?
Yes, sir.
হলো, তাহলে এবারে তুমি বলো, এবার কনভলভ সিগন্যালটা শিফট যদি ডেল্টা ফাংশন দিয়ে কনভলভ করলে সেই ফাংশনটাই পাচ্ছি, ধরো xt, ধরো মনে করো এটা দিস ফাংশন, ইফ আই কনভলভ উইথ দ্য ডেল্টা ফাংশন আই উইল গেট দিস ফাংশন, তাই তো? নাও ইফ আই শিফট দ্য ডেল্টা ফাংশন, দেন হোয়াট উড হ্যাপেন? দিস উইল বি শিফটেড।
Yes, sir.
If I shift delta function at this side, this will be shifted at this side. If I shift the delta function at this point, then it will be shifted. So তাহলে কি হলো ব্যাপারটা, অর্ডার প্লেনটা কি হলো, তাহলে কি উত্তরটা কি হবে? আরে ট্রেন অফ ডেল্টা ফাংশন, পিরিয়ডিক ডেল্টা ফাংশন দিয়ে আমি তাকে কনভলিউশন করব, তাহলে প্রত্যেকটা ডেল্টা ফাংশন যেখানে যেখানে এক্সিস্ট করছে সেখানে সেখানে ফাংশনটা অরিজিনাল অ্যাপিরিয়ডিক ফাংশনটা শিফট হয়ে যাবে। এই তো ম্যাম, এটাই তো বলবো, কি আছে বলতে, এটা তো কনভলিউশনের অ্যাপ্লিকেশন। এইটা আপনি যেটা বলতে পারলে না, এত ইজি জিনিস। যাই হোক, সো আচ্ছা কি বলছিলাম, হ্যাঁ, সো ইট ইজ 1 by t, so it's kind of a rectangular hyperbola function. Okay, now you just see that this is infinity, 0 পয়েন্টটা কোথায় গেল, এই যে 0, so this is infinity at t equals to 0, fine. Now at t equals to 1, if you approach from this side, from the left hand side, this is 1, because if you put t equals to 1, it is 1 by 1, 1, and if you approach from the right hand side, it is infinity, so there is a discontinuity, fine. And you just think, if you just integrate this signal, applying this condition, you just integrate, this is a periodic signal, please note, and if you just integrate this signal over a single time period from 0 to 1, what you will get? You will get infinity. You will get infinity. That means what? That means even though xt is periodic, please note, xt is a periodic function, no doubt, but it doesn't obey first Dirichlet's condition. That means the absolute integrability condition is violated. That means here the statement that is written, for the series to exist, means this, AKs will be finite, this AK finite hobe tobe series exist korbe. For the series to exist, the signal should be absolutely integrable. But here in this case, the signal is not absolutely integrable within a single time period. So you can say that even the xt is periodic, it doesn't obey first Dirichlet's condition, and so the Fourier series for this function doesn't exist. This is an example. মানে তোমাকে যদি কোথাও একটা বলা হয় যে একটা এক্সাম্পল দাও, but counter example though, it's a counter example in that sense, because এই বা এক্সাম্পল বলতে পারো, because এই কন্ডিশনটা যদি ভায়োলেট করে তাহলে ফুরিয়ার সিরিজ থাকবে। So this is one of the examples. Okay, so এটাই আমি বলছি যে পিরিয়ডিক সিগন্যাল হলেই যে তার তুমি একে সব ফাইনাইট হবে তার কিন্তু কোনো গ্যারান্টি নেই। দ্যাট ইজ দ্য পয়েন্ট। আচ্ছা, এটা হলো। এবারে সেকেন্ড কন্ডিশনটা কি আছে দেখি আমরা। হ্যাঁ, ম্যাক্সিমাম মিনিমাম। সেকেন্ড কন্ডিশনে বলছে যে যে এক্সটি, যে তোমার এক্সটি পিরিয়ডিক ফাংশন, এটার মাস্ট হ্যাভ এ ফাইনাইট নাম্বার অফ ম্যাক্সিমা অ্যান্ড মিনিমা ইন ওয়ান পিরিয়ড। Always when deal with a periodic signal, always concentrate and focus on single period, because whatever picture you will get for this period, that will be repeated, you know that. So ওভার যখনই কন্ডিশন গুলো লিখবে, দেখো প্রতিটা কথা একটু ভালো করে বুঝবে। আমি তোমাদের বলেছিলাম যে when you will write, and that you know already, you are already familiar with from your childhood days, in the school days, when you write some formula, law, principles, conditions, definition, there you cannot do any kind of twisting. You have to write as it is. You cannot do any kind of engineering there. So here also, even though you are writing the conditions, here also you should be very careful. This is very important, this line, in one period. If suppose you have written this, signal should have finite number of maxima and minima, and you put a full stop, what do you expect? What marks you will get? ধরো এই কন্ডিশনটার জন্য 2 নাম্বার দেওয়া আছে, কত পাবে? কত দেওয়া উচিত তোমরা বলো? বলো বলো। 2 marks is allotted for this condition, for each of the conditions. If you write the 3 conditions, you will get 6 perfectly. If you write, you will get 6. So, and suppose you have written like this, signal should have finite number of maxima and minima, or xt must have finite number of maxima and minima, and you put a full stop there. What do you expect? What you should get? What marks you should get?
0.
0. Exactly. 0. এবার বুঝতে পারছো কেন মার্কস রিডাকশন হয়? তুমি পরীক্ষার হল থেকে বেরিয়ে কি বললে? ওহ, কি পরীক্ষা দিয়েছি, সব ঠিক, সব ঠিক, দারুণ দারুণ লিখেছি, অসাধারণ। তোর বলো বলো না এরকম, অসাধারণ। আমাদের সঙ্গে অনেকে পড়তে লাগলো, পরীক্ষা দিয়ে বেরিয়ে এত ভালো লিখেছে, পরীক্ষায় মার্কস বলে দেখালো ফেল করেছে। সে তো বুঝতে পারছে না কি করে ফেল করলাম, এত লিখেছি, পাতার পর পাতা লিখে গেছি। তো ব্যাপারটা হচ্ছে এরকম। এই জন্য যখন পড়বে তখন না এই জায়গাগুলো এমফাসিস দিয়ে দিয়ে পড়তে হয়, কোন লাইনটা, কোন ওয়ার্ডটা, কোন ফ্রেজটা, ঠিক আছে, ইম্পর্টেন্ট। যেটা বাদ যাওয়া মানে সব বাদ যাওয়া, মানে মিনিংটাই পাল্টে যাওয়া, ডিস্টর্শন হয়ে যাওয়া, কাইন্ড অফ ডিস্টর্টেড হয়ে গেল মিনিং, ঠিক আছে। সো ইউ হ্যাভ টু আন্ডারস্ট্যান্ড দ্যাট, এন্ড দ্যাট কামস ফ্রম দ্য ম্যাচিউরিটি। তোমাকে তো প্রত্যেক জায়গায় পয়েন্ট, এটা তো স্কুল নয় যে প্রতি জায়গায় হ্যামার করতে হবে, প্রতি জায়গায় তোমাকে পয়েন্ট আউট করতে হবে, জাস্ট লুক এট দিস, লুক এট দ্যাট পয়েন্ট, লুক এট দিস, রিমেম্বার দ্যাট, রিমেম্বার দিস। নো, ইট ইজ নট পসিবল। দ্যাট কামস ফ্রম দ্য ম্যাচিউরিটি। তোমরা অনেক ম্যাচিউর, যারা বিএসসি বিটেক করছো তারা ইভেন ম্যাচিউর, অলরেডি কলেজ পার করে এসেছো। সো 3 বছর কলেজ পড়েছো, আর তাও আবার বিএসসি তে এত ভালো রেজাল্ট করেছো, তবেই তোমরা রেডিও ফিজিক্সে পেয়েছো। সো তোমাদেরকে আমার কিছু বলারই নেই। আর যারা ডাইরেক্ট বিটেক করছে তাদেরকে তাও আমি একটু বলতে পারি, বিকজ তারা জাস্ট স্কুল লেভেল থেকে, মানে মাঝখানে কলেজ পার্টটা থাকে না, দ্যাটস ট্রানজিশন ফ্রম স্কুল টু ইউনিভার্সিটি। ওকে, সো এটা তো ঠিক কলেজ নয়, এটা ইউনিভার্সিটি অ্যাকচুয়ালি, সো ডাইরেক্ট ইউনিভার্সিটি। সো এইখানে একটা গ্যাপ হয়ে যায় অনেক সময়, ঠিক আছে। সো আমি তাদের জন্য বেশি করে বলি, কারণ তাদের ক্ষেত্রে প্রবলেম, যারা অলরেডি কলেজ পড়ে এসেছে তারা তো অলরেডি কোয়াইট ম্যাচিউর। সো কিছু বলার নেই এখানে। এবং সেই কনটেক্সটে বলছি, যখন কোনো কিছু পড়বে, আমি এখানে আমি জাস্ট একটা পয়েন্ট ডিসকাস করলাম আমার চোখে পড়লো বলে, বাট এরকম প্রচুর আছে যেটা হয়তো আমি বলিনি, ঠিক আছে। এরকম সব সাবজেক্টেই আছে, সেগুলো একটু বুঝে বুঝে পড়বে, না হলে কিন্তু গন্ডগোল। পরীক্ষায় মার্কস যখন কম পাও তখন তোমরা বলো যে কেন কম পেলাম, মাস্টারমশাই বা দিদিমণি কম দিলেন। ব্যাপারটা কিন্তু সেরকম নয়, কেউ তোমার শত্রু নয় এখানে যে তোমাকে মার্কস কম দেবে। আর মার্কসটা আমার বাড়ির সম্পত্তি নয়, ঠিক আছে। মার্কস দেওয়ার জন্যই আমরা বসে আছি। তো তোমরা লিখলেই মার্কস পেয়ে যাবে, ঠিকঠাক, আর কোনো ব্যাপার না। এই যেমন এই পরীক্ষা, এই যে তোমাদের যে ডিসকাশন গুলো করলাম ক্লাস টেস্টে, কেন করলাম? এটা করার উদ্দেশ্য কিন্তু একটাই, জাস্ট টু পিন পয়েন্ট যে কোথায় কোথায় কোন কেসে কোন সিচুয়েশনে তোমাদের লিখছো, ইউ আর রাইটিং সামথিং অর ইউ আর ডুইং সামথিং, বাট ইট ইজ নট প্রজেক্টেড ইন দ্য ওয়ে ইট শুড বি, the way it should be, or may sometimes carry different sense which should not, sometimes misleading, which should not, মানে you should be very careful while writing. এমনি বলার সময় আমরা অনেক কিছু বলে ফেলি, কিন্তু যখন এক্সামিনেশন হলে তুমি পরীক্ষার খাতায় কিছু মানে পরীক্ষার হলে বসে কিছু লিখছো, আনসার স্ক্রিপ্ট লিখছো কিছু, তখন you should be very careful. Each and every word you are writing, for that you are solely responsible, and you have to take that responsibility. You cannot bypass that. যা খুশি এটা লিখে দিলাম, whatever I thought I have written, whatever came in my mind just written. No, that is not going to work for you. এটা বারবার বলছি। কিন্তু আর একটা পয়েন্ট যেটা আমি ভাবলাম পরে বলবো, ঠিক আছে আমি এখনই বলি, সেটা হচ্ছে যে তোমরা ক্লাস টেস্টে যেটা করেছো, দ্যাট মেবি মানে there are some groups or clusters, আমি একদম ধরে ধরে বলতে পারি, আমার কাছে খাতা এখনো রয়েছে, ঠিক আছে। তো পয়েন্ট হচ্ছে যে কপি পেস্ট করেছো, there may be one or two sources and there may be multiple sinks. এই সোর্স এন্ড সিঙ্ক এর মধ্যে যে কমিউনিকেশনটা হয়েছে, আর এইটা একদম মানে ধরো এক্স যেখানে মিস্টেক করেছে, ওয়াই সেখানে মিস্টেক করেছে, আবার এক্স যেখানে কেটেছে, ওয়াই সেখানে কেটেছে। এক্স যে লজিক দিয়েছে, যেভাবে দ্য ওয়ে দে হি অর শি হ্যাজ গিভেন, ওয়াই সেইভাবে দিয়েছে। মানে সে মাল্টিপল টাইমস, মানে এখন কিছু কিছু গ্রুপ বেজে কিছু কিছু ক্লাস্টার্স ফর্ম করেছো তোমরা, ঠিক আছে, এদের মধ্যে একটা কমিউনিকেশন হয়েছে, একটা চেন ফর্ম করেছো অনলাইনে। তো সেগুলো সবই আমরা বুঝি, ঠিক আছে, না বোঝার কিছু নেই। এখন পয়েন্টটা হচ্ছে যে ঠিক আছে, আমি আবার তোমাদের ওয়ার্ন করছি, ক্লাস টেস্টে যা করেছো করেছো, কনসিডার এই এগেইন it's a in restricted sense. Okay kind of okay allowed, okay considered, but it's sufficient. But in examination I will impose the necessary condition. If you satisfy that, if you can follow that, if you obey that, then you will be allowed. If you not, direct, straight away cancelled. No consideration, no sense of restriction, no sense of incompleteness. It's a complete thing I will give. Copy paste যদি হয়েছে even a single person, I will not bother who is the source. I will not go for that. I will not go for the investigation, that who is the source, who are the destinations or the things or like that. I will not go for that. Who is the responsible, who is the main culprit, I will not look into it. It is not my job, my duty. I will take the answer script as it is, and whatever the things that will be reflected from the answer script, I will evaluate the answer script just according to that or accordingly. Okay, understood? If there is a single person copy paste kind of thing, or one copied from other, or maybe from multiple sources, or from the one source to one to many, or many to one, this kind of interaction if this is there, okay, so you will be penalized, no doubt about that. I'm imposing necessary condition, not sufficient. If it is, then it is. If not, then not. So you should be very careful. And as I mentioned, that I will actually give you before, I think 1 or 2 days before the examination, I will actually circulate a set of regulations or instructions which you have to follow in toto. In toto means in toto, 100%. One violation of each instruction lead to 10% deduction of marks. Suppose you got 60 and you have violated suppose 2 instructions, then 10%, that means 20% will be deducted from 60, and that will be your resultant. Obviously, sometimes even though you are passed, but due to the violation of instruction, you may fail. It may happen, because below 50 means it is a fail, supplementary. So again, as I mentioned, whatever you will do in the examination, whatever you will do, that is up to you. You can do anything and everything. But for each of your act, you will be solely responsible, not the teachers. For each of your activity, the way we will act, the way we will react. Getting the point? Is it clear what I'm trying to say? Got it?
ইয়েস স্যার।
এটা মনে রাখো, কপি পেস্ট যদি করতে গেছো, সবাইকে বলছি, যেটা করেছো আমি বুঝতেই পারছো আমি কি বলতে চাইছি। হ্যাঁ, ওই যেটা করেছো ভুল ঠিক আমি কিছু দেখবো না, কে সোর্স কে ডেস্টিনেশন কে সিঙ্ক আমি সব কিছু দেখবো না, কে রেসপন্সিবল আমি কিছু দেখবো না, স্ট্রিক্টলি বলে দিচ্ছি। আর ইনস্ট্রাকশন যেভাবে বলে দেবো সেইভাবে ফলো করবো, কোনো কনসিডারেশন হবে না। ইন্টারনেট কাজ করছে না, সিস্টেম কাজ করছে না, অমুক এই হয়েছে সেই হয়েছে, ওসব এমনি ঠিক আছে, ক্লাসে চলে। খুব জোর হলে ম্যাক্সিমাম আমি যদি রেস্ট্রিক্টেড সেন্সে দেখি তাহলে হয়তো ক্লাস টেস্টে চলতে পারে, যেটা আমি করে দিয়েছি অলরেডি। তোমরা এই মার্কস পাও না আদারওয়াইজ, যেটা পেয়েছো ওনার অ্যাভারেজ তোমরা ভালোই মার্কস পেয়েছো, সেটা পাও না, কিন্তু আমি কনসিডার করেছি বলে পেয়েছো, ঠিক আছে। বাট ফাইনালি কিন্তু সেটা হবে না, এটা মনে রাখো। মানে অন্য কে কি করে আমি বলতে পারবো না, আমি আমার কথা বললাম, সুতরাং আমার ব্যাপারে কিন্তু আমার পার্ট এটা হবে না। আমি আবার স্ট্রিক্টলি বলে দিচ্ছি তোমাদের ক্লাসে, একদম পরিষ্কার ভাবে ওপেন, ঠিক আছে। দ্য ওয়ে ইউ উইল অ্যাক্ট, the way we will react, and for each of these, whatever you will write, the way you will act, for each of such activity or the things, you will be responsible, ঠিক আছে। এটা মাথায় রেখো, সেইভাবেই তোমরা অ্যাক্ট করবে। আচ্ছা, so second condition আমরা যেটা ডিসকাস করছিলাম, we were basically discussing about this one period, in one period that this particular phrase is important. So xt, any signal xt that I have written here, xt obviously should have a finite number of maxima and minima. Now again, the another example here, look at this. This example says that xt is sine 2 pi by t within the interval 0 to 1. Now probably you can remember in the last class we have introduced a function, I think this one, this sine 1 by x or 1 by t. And the purpose of introducing this function is this. This function itself is not periodic, as you know, we have already discussed. But the point is, we can make it periodic, like what we did here, or what has been done here. In this example, it is the same function, sine 2 pi by t, sine 1 by t kind of function. And this is actually a periodic function. It by itself is aperiodic, but we have forced this function to become periodic. আচ্ছা, এখানে বলে রাখি, এখানে একটু ডিস্টর্টেড হয়ে গেছে, ছবিটা স্ন্যাপ নিতে গিয়ে, ঠিক আছে, এখানে ডিস্টর্টেড হয়ে গেছে, অ্যাকচুয়ালি এটা সাইনুসয়েড ফাংশন। তো একদম, তো the point is, within this interval we are taking this from this 0 to 1, 0 to 1 কেন এখানে 2 পাই দিয়ে মাল্টিপ্লাই করা হচ্ছে, বুঝতে পারলে যে ফার্স্ট ক্রসিং জিরো ক্রসিংটা তো একটা ইনফিনিটিতে, তো তারপরেরটা বেসিক্যালি 1, বিকজ ইট উইল বি 2 পাই। The first k pi, the argument is k pi, plus আমরা ডিসকাস করেছি। তো সেখানে যখন t এর ভ্যালু তুমি পুট করছো, t এর ভ্যালু যখন 1, তখন এটা হচ্ছে 1, তখন এটা হচ্ছে 2 পাই, ঠিক আছে, t এর ভ্যালু যখন 1, সো 2 পাই, এই সেন্সে এরা এই অবধি জাস্ট করেছে। বাট এনিওয়ে, সেটা খুব একটা বড় ব্যাপার না। মেন ব্যাপারটা হচ্ছে ইট ইজ এন অ্যাপিরিয়ডিক, it is by itself it's an aperiodic function. Now we are taking a portion of the function from 0 to 1 within that interval rather, and we are forcing the function again by applying the same mathematical trick or method. We made it or force it to become periodic, or force it to repeat itself after every interval of 0 to after every interval of 1 unit of time. Okay, so it's kind of a repeated. So in this way the function become a periodic function. In this way, the function becomes a periodic function. Okay, whose period is 1, is 0 to 1, suppose 1, 0 to 1 or 1 to 2, 2 to 3, like that, 1. Now the point is, you know already the behavior of the function. You know how this function behaves. As you are moving towards the left hand side or towards the 0, the number of oscillation increases so much that actually it is difficult for the function to get settled. That means, you know, the limit, okay, x tends to, or t tends to here, t tends to 0, xt will be almost you cannot define, undefined kind of. So that means ideally you can say that maybe infinite number of that means the zero crossing points are so much, suddenly overlapping with each other. Number of oscillations are like an infinity. So that means what? That means even within the one time period, this function has infinite number of maxima, and infinite number of minima. But the condition says, the second condition says there should be finite number of maxima and minima within a period. But for this particular function concerned, it shows infinite number of maxima and minima within a period. So again, it is violating the second condition, second Dirichlet's condition. And that means this function doesn't have the Fourier series. That function cannot be expanded into Fourier series. Now the question is, can you tell me whether this function is obeying the first condition of Fourier Dirichlet's first condition? That is whether this function is absolutely integrable. Whether this function is absolutely integrable. কি হলো? চুপ করে শুনতে পাচ্ছ?
Yes, sir.
হ্যাঁ, absolute integrability condition কি violate করছে, মানে first Dirichlet's condition? আচ্ছা করে দেখো তো, 0 to 1 within a one period, 0 to 1 mod of sine argument 2 pi by t dt করে দেখো কি পাবো, absolutely integrable হচ্ছে কিনা। ঠিক আছে, মানে এরিয়া আন্ডার দ্য কার্ভ ফাইনাইট হচ্ছে কিনা উইদিন দ্যাট পিরিয়ড করবে। ঠিক আছে, করে দেখো। আচ্ছা, আমরা থার্ড কন্ডিশনে আসি, এটা করো ততক্ষণে তোমরা। থার্ড কন্ডিশন হচ্ছে the signal should have, or xt should have, finite number of finite discontinuities in one period or within a single period. আচ্ছা, এখানে একটা জিনিস দেখো, এই যে ফার্স্ট এক্সাম্পলটা আমরা যেটা নিয়েছিলাম, ফাইনাইট নাম্বার অফ ফাইনাইট ডিসকন্টিনিউটি, ইফ ইউ ফলো দিস এক্সাম্পল, দিস পার্টিকুলার এক্সাম্পল, ঠিক আছে, উইদিন দিস পিরিয়ড, look at that there is a discontinuity within any single period, there is a discontinuity, but the height of this discontinuity is infinite. Please note it. The height of the discontinuity or the jump, the step jump করছে, the jump height হচ্ছে infinite. So, but within the interval, there is only one such discontinuity. That means the number of discontinuity is finite. The number of discontinuity, here it is written that number of there should be finite number of finite discontinuities. That is two things to remember. Finite number, the number should be finite, and the height of the discontinuity should be finite. There are two finite things. Here, in this case, the number of discontinuities within one period is finite. This is only one discontinuity. But the height of discontinuity is not finite, that is infinite. So ft equals to 1 by t has one infinite discontinuity, and that is not permissible because the step height should also be finite. That is the thing. Now again, this condition, this finite number of finite discontinuities within one period, this is again just a sufficient condition. Like for this case, it may, like you know that Fourier, actually this is not absolutely integrable within a single time period. That means AKs actually not exist, or you can say they will blow up, okay, and so Fourier series doesn't exist. But the point is, even if if you only follow this particular condition, the third condition alone, that if you only check whether there is a finite number of finite discontinuities in one period, you can show that this condition is just a sufficient condition itself, not necessary. That means there are functions which does not obey this condition but still have a Fourier series. Like, you just go back, look at this function. Look at this function within a single time period. This function goes up to infinity. That means there is a discontinuity. So this impulse train or chain of delta function, here within any time period, if you take, you have a delta function. The delta function means what? Height is infinity. That means there is this sudden jump. And that means discontinuity. The discontinuity height is infinity. So it's an infinite discontinuity. But the number of discontinuities is finite. That is okay. Like the 1 by t function, x equals to 1 by t. But for this case, if you calculate the area under that's an absolute integrability condition, if you check out the first condition, if you check, then you will see that this is absolutely integrable. You know that. Absolutely integrable. And if this is absolutely integrable, that means AKs exist, and that happens. Look at here. Look at here. All the DNs exist করছে, বুঝতে পারছো কি বলতে চাইছিলাম? এক্সিস্ট করছে, এবং you can expand it into Fourier series, even though the magnitude of the discontinuity for the function is infinity. So the Dirichlet's condition, third condition, is violated here, but still Fourier series exists. So এটা kind of বলতে পারো, তাহলে এখান থেকে বলা যেতে পারে যে এটা it's just a necessary condition, not sufficient. তবে যদি কন্ডিশন, মানে ব্যাপারটা হচ্ছে কি, কন্ডিশনটা যদি স্যাটিসফাইড হয় তাহলে ইট ইজ গ্যারান্টেড যে ফুরিয়ার সিরিজ এক্সিস্ট করবে। বাট যদি কন্ডিশনটা স্যাটিসফাইড না হয় তাহলে কিন্তু এটা দিস ইজ নট গ্যারান্টেড দ্যাট দ্য ফুরিয়ার সিরিজ উইল নট এক্সিস্ট, এটা গ্যারান্টি না। বা উল্টো দিক থেকে বল, অর ইন রিভার্স ম্যানার ইউ ক্যান সে, যদি কারো ফুরিয়ার সিরিজ এক্সিস্ট করে তাহলে এটা গ্যারান্টেড নয় যে সে থার্ড কন্ডিশন স্যাটিসফাই করেছে, এরকম ভাবে বলতে পারে। ঠিক আছে, এনিওয়ে, তো পয়েন্ট ইজ দ্যাট দিস এক্সাম্পল ইজ গুড এনাফ, আই থিঙ্ক। আচ্ছা, এখানে একটা কথা, একটু জিনিস দেখো, আমি এটাও আগের দিন বলতে ভুলে গেছি। ইট ইজ বেসিক্যালি এ ট্রেন অফ ইম্পালস ফাংশন, ইম্পালস ট্রেন অর চেইন অফ ডেল্টা ফাংশন, যেভাবে বলো না কেন। আর এর যখন ফুরিয়ার সিরিজ আমরা করছি, দেখো তখন আমরা যেটা পাচ্ছি, লুক এট দিস এক্সপোনেনশিয়াল, এটাই দেখো, from minus infinity to plus infinity, again this is a train of delta functions. This is also a train of delta function or chain of delta function. But what is the difference? Difference is here the height of each of the delta function is infinity, like an analog delta function, right? Digital analog delta function or continuous time delta function যেটা হয়, ঠিক আছে, যে t equals to for different values of t, it is basically where this function exists, it is actually showing, and it actually blows up, showing the value of infinity. But here, so the arrow-headed functions. But here, when we got its spectrum, and when we represented the spectrum in a pictorial form, there also we are getting as if the delta function. But here we are not putting the arrow. It is some kind of, the behavior is some kind of a digital delta function or discrete in the discrete time case. The way we plot the delta function, it is the absolute, the value is exactly 1 or something like that. Here it is not 1, it is 1 by t naught. So it is also a delta function. It is also a train of delta function, the spectrum itself. So the delta, ওই জন্য একটা কথা বলা হয়, দেখবে একটা স্টেটমেন্ট পরীক্ষায় তুলে দেওয়া হয় যে তুমি ট্রেন অফ ডেল্টা ফাংশনের ফুরিয়ার সিরিজ একটা ট্রেন অফ ডেল্টা ফাংশন পাবে, প্রমাণ করো, প্রুফ করো। এই দুটো ডেল্টা ফাংশনের মধ্যে কোনো ডিফারেন্স আছে কি? জাস্ট লাইক দ্যাট, এরকম ধরনের একটা কোশ্চেন দেওয়া হয়। এগুলো খুব ট্রিকি কোশ্চেন, মানে only if you understand and your concept is clear, then only you can answer. It is not straightforward. এগুলো সবসময় straightforward question থাকে না এইভাবে। So এটা জাস্ট আমি একটু পয়েন্ট আউট করে দিলাম এই কনটেক্সট। আচ্ছা কি বলছো থার্ড কন্ডিশন। আচ্ছা থার্ড কন্ডিশনের একটা দেখো এক্সাম্পল দেখ। Very great third condition. Example. It's a very nice and very elegant example. এই এক্সাম্পলটা বলছে এই ফাংশনটাকে ভালো করে লক্ষ্য করো। Look at this function very carefully. Within the time period. This time period is 8. Suppose one time period 0 to 8. This is like a the height steps and then height is not constant. Height is changing. It's like a staircase function, but the step height is not constant. Okay, this is again it's a periodic function. If you take one particular, if you look at particular interval or period, it is aperiodic obviously, but you have actually forced it to repeat but different times, different intervals, so it or equal amount of interval or uniform interval, then it becomes periodic. So for this periodic function if you just carefully look into one single period, so what is happening within this single period? Look at the definition of the signal. Xt is 1. Xt is 1 precisely equals to 1 for 0 to t. 0 to t means this is the interval from 0 to 8. 0 to 8. So you are taking the 50% of the interval. 50%. This 50%. That is 0 to 4. And within 0 to 4, the value is precisely equals to 1. 1. Exactly 1. Now, again, how the function is behaving. So for the next interval, whatever the remaining interval is, that's the 50%, other 50%, other half, you are taking the 50% of that. That means it was 4, the difference was 4. Now you are taking the 50%, so it becomes 2. So that means 4 plus 2, it will be 6. This is 6. So from 4 to 6, this value becomes the half of this initial value. So there is a jump. So there is a jump, and it was initially 1, and its half is half. It's half. And it remains constant within this interval. Half. Again, whatever remaining part is there, that means 6 to 8, the remaining part is 2 value. You take the 50% of that. That means what? 2, 50% 1, so that means 7, up to 7. Up to 7. So 7, from 6 to 7, whatever value this function has within this interval, it just cut down by 50%. So 50% means half it, 50% is 1 by 4. So 1 by 4. Again, that is a sharp change or transition or a step height. Okay. And again, it becomes 4 and 4 remains up to this. Again, whatever remaining part you have, that is 7 to 8, that is 1. Difference is 1. You take the 50% of that. That is 0.5. So 7.5 up to 7.5. So again, that value, the step height become the half of this. 1 by 4 and half koto, 1 by 8. So 50% of that. In this way, actually you can understand, you are taking a long distance, a particular distance, 1 by 8. Dividing it by 2, again dividing the rest by 2, again dividing the rest by 2, by 2, 2, 2, 2 in this way. You can never reach up to 8. And the function also will never reach to 0. You can never touch. You know that mathematically. So you can never touch. So the function will looks like this, always like a steps, like a hanging. The 50% of the rest 50%. Again, you are just making half, taking the half of the rest 50%. Again, for the rest 50%, you are taking the half of its previous value. Again, for the rest 50%, you are taking the half of its previous value immediate, like this, and it's going on and on and on. Like it can never touch. That is why look at here. They have not touched this axis or this point. It can never touch. It can never reach up to the destination. সেই কেকের অ্যানালজি তোমরা যখন ছোটবেলায় অঙ্কটা শিখেছি মনে পড়ে কেক কাটা একটা কেক ছিল তাকে হাফ করলে একদিন খেলে মাস্টারমশাই যে অ্যানালজি দিতেন তারপরে যা কেক পড়ে রইলো ফ্রিজে তার হাফ নিলে আবার খেলে যা পড়লো তার হাফ নিলে এইভাবে কেকটা কোনোদিন শেষ হবে ইট ইজ সামথিং লাইক দ্যাট সো দ্য পয়েন্ট ইজ for this is the periodic function. Now for this periodic function you just see within one interval you have the number of discontinuities. Please note the number of discontinuities is actually infinite because in this way it will basically go on and on forever and ever. So the number of discontinuities are infinite, but each each discontinuity has a finite height. So the step height, discontinuities are finite, and the step height is finite. But the number of such finite discontinuities are infinite. So this function, this particular function actually, violates the third Dirichlet's condition. Now the question is whether this function obey Dirichlet's first condition. First condition কি obey করছে?
না,
এই কি না? area under this curve is always finite. First condition কি? Absolute integrability না? area under area কি কখনো infinite হবে? Always finite. আগেরটার কি তো তাই ছিল, যেটা তোমরা এখনো বলতে পারলে না। যাই হোক, so area is always finite. তুমি যদি absolute integrability দেখো, so it is absolutely integrable. Area is always finite. Now the question is whether it follows second Dirichlet's condition. Second Dirichlet's condition. করছে? Dirichlet's second condition follow করছে? Second conditionটা কি ছিল মনে আছে? ম্যাক্সিমাম এই ফাইনাইট নাম্বার অফ ম্যাক্সিমা এন্ড মিনিমা ইন ওয়ান পিরিয়ড। করছে? করছে না করছে না?
করছে স্যার।
করছে সবাই শিওর? সেকেন্ড কন্ডিশন ভায়োলেট করছে মানে কি করছে, মানে কি করছে, মানে ওবে করছে না ভায়োলেট করছে?
ওবে করছে।
সেকেন্ড কন্ডিশন ওবে করছে। The second condition is not at all applicable for this particular signal concern. কেন? Because in the second condition it is given the number of maxima and minima. Regarding the maxima and minima, is the definition of maxima and minima applicable here? তোমরা অঙ্কে পড়েছিলে?
না স্যার,
Applicable নয়।
চেঞ্জের জন্য
Exactly. তার মানে applicable নয় মানে কি differential coefficient at the spot value of time, যেটা তুমি বলছো, of the argument, that is not applicable. It is basically on an interval. Look at this. It is not for a spot value. It is for an interval. It is for an interval. So technically the definition of maxima and minima is not applicable. That means the second condition is not at all applicable. This is not maxima. আমরা বলি বটে মুখে, it's again a slip of tongue, technically wrong. যেমন আমরা বলি DC signal, technically wrong. But actually here also this is not maxima or minima concept. Maxima minima concept is not at all applicable. So second condition is not at all applicable. Here you have to say the lowest value of the highest value, something like that. এরকম ধরনের টেকনিক্যাল টার্ম ইউজ করতে হবে, ঠিক আছে? ম্যাক্সিমাম মিনিমা নয়, বিকজ অ্যাজ পার দ্য ডেফিনেশন দ্য ম্যাক্সিমাম মিনিমা ইজ নট অ্যাপ্লিকেবল, ঠিক আছে? আচ্ছা, আরেকটা পয়েন্ট আমি একটু জাস্ট বলতে চাই এখানে না, ইজ অ্যাজ দেয়ার ইজ এ ডিসকন্টিনিউইটি, আই থিঙ্ক though they have written like that, but I think you should remove this equal to sign, this equal to sign, okay? This equal to sign, just remove it. Actually that is a discontinuity. So like a definition of unit step function, okay? So at t equals to 0, this is not defined. Similarly, at this point, at the points of discontinuity, it is not defined. It should not be defined. It is somewhere in between this and this. And then for your purpose, for your convenience, you can define. That is different thing. Okay, you can define any value, this value, in between anything. Okay, 50% or whatever. That is, but as far as the definition is concerned, I think, to me, if you follow the definition of unit step function, and if you just extend the concept here, I think you should not use this equal to sign. Then I think it will be technically more correct. কি বলছো? আমার সঙ্গে এগ্রি করছো তো এই ব্যাপারে? দেখো আমি যেটা বলছি? হ্যালো, শুনতে পাচ্ছ?
হ্যাঁ স্যার।
Yes, sir.
ওকে, তো এটা গেল আমাদের থার্ড কন্ডিশন। তাহলে আমরা দেখো একটা পয়েন্ট আমরা যেটা দেখলাম, যে আমরা এখান থেকে বলতে পারি যে তোমার ধরো আমাদের মনে করো, আচ্ছা এটাই থাক। ধরো আমাদের যদি একটা ফাংশন থাকে, if we have a function x of t which obeys Dirichlet's condition, so we can say for that function Fourier series that exist, okay, and because the conditions are just sufficient conditions, and from that means we can actually find the AKs. We can find the AKs. Okay. Now if none of the AKs blow up, then the question, which is obviously the important question in this context, is that, as I mentioned, that whether limit, n tends to infinity, summation, as I've already written this, k equals to minus n2 plus n ak e to the power j k omega naught t, whether this tends to or converges to xt. That was the question we asked. Now, as I mentioned before, Dirichlet came, or in the earlier before the Dirichlet period actually. So before Dirichlet came, the answer of this question, or the conditions, actually the earlier conditions was, the energy condition. Okay, and we have discussed that it is not necessarily true. That means the values of the that xt and this summation actually are not necessarily same for all values of t, but in the energy sense, that is the error signal or the error function defined by the difference of these two, and if you take the mod of that and then integrate take the in the square of the modulus and then integrate over a single diode, and if that tends to 0, then in that sense we can say that this tends to this or converges to this. That was before Dirichlet. But when Dirichlet came, as I mentioned, these are some of the things actually changed. So when Dirichlet came, Dirichlet told that, or Dirichlet showed, I should not say told, he showed again mathematically that actually he was a mathematician, so he did everything mathematically. Okay, so he mathematically showed that no, this is actually true. Means not only the AKs will exist if that first condition is satisfied, but also this summation, okay, actually will be same as this. That is, they will be identically equals to this for all values of t. For all values of t, but except, that is for all values of t, I should write except, but that is except, other than at the point of discontinuity, except at the point of discontinuity, this function and this function, or the values for this function and this function, for all the values of t will be exactly equal or the identity. That Dirichlet law. If AKs exist. Okay, so the energy sense actually that condition was no longer valid. Now the point is, here again another concept was introduced at the point of discontinuity, another fallacy. So the point is, what do you mean by the point of discontinuity of a function? how it is defined. Actually, as I mentioned, just now I mentioned, the point of discontinuity. The discontinuity is not defined in that way. Discontinuous function, how will you define? Or better to say, what value of this function you will define at the point of discontinuity. That is the point. Because you can define any value. That is a specific value. That is why it is kind of not defined. So there is the definition of a particular value or assignment of a particular value is not there. So that means you have to assign some value. You have to do it. As I mentioned, আমি প্রথম থেকে একটা কথা বলে আসছিলাম, মনে পড়ছে এবার, যে as per your convenience as an engineer, whatever actually works for us, we take that. We are not like a mathematician or the physicist. We are not rigid. We are in that sense. We are a bit lenient. We are a bit flexible. Whatever works for us, we will take it. We'll accept that. So here, in this case, we accept that, okay, for this case to be satisfied, okay, we will define a value. At the point of discontinuity, we will define a value. And so the meaning that the summation converges to the function, the value of the function at the point of discontinuity is that we will first define some values at the point of discontinuity. And what is that value? Actually, Dirichlet defined, even though he was a mathematician, but he defined. And he defined how he defined. He defined that Dirichlet, it is again not my statement, not my definition. It's a definition given by the statement given by by Dirichlet at that point. He told that where there is a point of discontinuity, suppose point of discontinuity as t equals to t naught. Suppose if there is a point of discontinuity, then the summation converges to the average or the mean value, of xt, suppose, at the vicinity of t naught. That means what I'm trying to say, it implies that this summation actually converges to at t equals to t naught, there is a discontinuity. So obviously the value of the function at the vicinity of t naught, that means just immediate left and just immediate right. If you take two values, that is t naught minus and just immediate right x of t naught plus, if you add this 2 and divide by 2, that is the the average or the mean value to find out. So t naught is the point of discontinuity, and this is the value we are defining. We are defining at that point for the function. For the function means for this xt or ft. Then, if you define like this, again as per our convenience, look at here. Okay? So, or demand or requirement. আমি ডিফাইন করলাম, আবার আমি বলছি না, সরি, মানে ডিরেক্টলি ডিফাইন করেছেন। সো ডিফাইন করলেন, সো করে উনি বললেন যে এই যে ভ্যালুটা আমি পেলাম, দ্য অ্যাভারেজ ভ্যালু দ্যাট আই এম গেটিং, this summation converges to, that means the summation is exact, এখানে converges মানে exactly equals to, identical, যদি তুমি এইভাবে ডিফাইন করো, even at the point, তার মানে কি হলো, এখন for all values of t, the convergence actually carrying its true sense, or you can say the condition is kind of complete in that sense. এই জায়গাটাই দেখো আমরা স্লাইডে দেখিয়েছিলাম, মনে আছে তোমাদের? এই differ এটা হলো jump discontinuity t naught corresponding to Fourier set, t naught converges to the mean of this f t naught plus t naught minus and mean of this by divided by 2, এই দুটো ভ্যালু। এবারে দেখো সেটাই এক্সাম্পলেও করা আছে, এক্সাম্পলটা যদি তুমি ভালো করে দেখো এখানেও তাই করা আছে, এই ছবিটা পার্টিকুলার দেখানো আছে। অ্যাকচুয়ালি এই ছবিটার রেসপেক্টে আমি তোমাদের বলেছিলাম, আই হ্যাভ অলরেডি টোল্ড ইউ দ্যাট the summation, it is basically the summation. The signals we are getting are basically the result of the summation. Now, you are actually summing up some continuous signal, some sinusoids, whether sine or cosine or whatever. All are the continuous signal. So when you are doing the summation, even though it's a finite or even infinite, suppose, it cannot be discontinuous. The summation of its continuous functions cannot be discontinuous at any point. Okay, but the summation will always give you continuous values for all the values of t. So that is why at the point of discontinuity, there is no question of convergence, okay, of the summation to any particular value of the function xt, unless you define it in a particular manner in this particular context, which Dirichlet did. Otherwise, there is a question of convergence because it is a discontinuous thing. It's a discontinuous part. And here we are saying that the summation of a number of continuous signals will lead to a discontinuous value. No, this is not possible. Discontinuous value is not defined. And continuous thing cannot become discontinuous unless you define in a particular way or give a particular value of that function upon that point in this particular context. And that is the meaning of convergence, which Dirichlet did. Another thing you just note that suppose this is one period of this signal. Now suppose, let's come from here. Suppose this is one period. Within one period, look at what things are going on, what activities going on when you are trying to replicate or represent this squared blue colored signal with this red colored signal. Now look at it. There is only one oscillation. Start from here. On a complete oscillation within one period of the blue signal, there is only one complete oscillation, right? When you look at this picture, look at the oscillation, number of oscillations. This is 1, 2, 3, suppose. Okay, 3 oscillations. You can come up to this point also, doesn't matter. 3. Now, if you follow this, look at this. 1, 2, 3, 4, 5. Okay, 5 oscillations. If you follow this, 1, 2, 3, 4, 5, 6, 7. So what is the meaning of this? Its meaning is, that means when there is only one oscillation of with which you are actually representing or approximating the original signal ft or xt. There is only one oscillation. That implies it is the first harmonic or the signal and the fundamental itself. When there is a 3 oscillations within a one period of the signal, that implies you have the third harmonic. That means n equals to 3. Here it implies capital N equals to 1. In the summation, k equals to minus n to plus n tends to infinity. In that summation, that n value I'm talking. So n equals to 1, here n equals to 3. Here, number of oscillations are 5 within one period. That means n equals to 5. Already you have added the 5th harmonic. Right? Here, the number of oscillations are 7. That means n equals to 7. So here you have added up to 7 harmonic. So 1, the odd harmonics are present. You have already done the Fourier series. So mathematically, 1, the first is the fundamental, then the third harmonic, then the 5th harmonic, then the 7th harmonic. Then after adding the 7th harmonic, that is n equals to 7 up to, the resultant signal we got looks like this. The resultant signal we got looks like this. And if you follow the pattern, how the changes are happening or where the changes is happening, if you just look at in this method of approximation or representation. Now our objective is to check that whether the summation converges to, because Dirichlet told you, and he actually proved that for each and every value of t, the summation will converge to the function except at the point of discontinuity where you are defining the value like this, and then it will happen. Now, if you just look at this carefully, now suppose you take any particular pulse, suppose this. And if you follow the mode or the type of oscillation or the variation of the summation, it is basically the summation, no? This signal, the red one, is summation. If you follow it, you just look at here. Here is a, just a minute. Look at here. Here is the overshoot. More value you are getting than expected. And here there is an undershoot. It is called overshoot. This is called undershoot. Now suppose if the signal value is 1 here and 0 here. So it's a step height is 1. Suppose, for example. Now, if you just follow these oscillations, that when there was only one harmonic, that means the fundamental, it's the first case. There was also কার্সারের মুভমেন্টটাই প্রবলেম হয়ে যায় আমি টানছি এখানে চলে যাচ্ছে here is the overshoot, here is the undershoot at the vicinity of the discontinuity. When there is you have had the third harmonic along with the first, so what is going to happen? Look at here, overshoot, undershoot at the vicinity. Fifth harmonic, overshoot, undershoot at the vicinity. Seventh harmonic, overshoot, undershoot. If you add on like that ninth harmonic, that will be total 9 number of oscillations will be 9 from this point to this point. But again, as you can see, that look at the area under this overshooted portion or the undershooted portion. Are you getting the point? The area is actually reducing. Can you follow it?
Yes.
Area is reducing, but the height, this height is almost same. It's not varying too much as such. Okay? And these are the points to observe. And this peak or the maximum, this is the maximum or the minimum, are actually coming closer from these two directions. They're coming. Look at the position of this maxima here. Look at the position of this maxima here. Look at the position of this maxima here. Look at the position of this maxima. Even if you add, the position of the maxima will come here in this way. The position of the minima. So they are kind of coming closer and closer and closer to each other at the point of it. That means towards the point of discontinuity. This is coming from both the directions. Are you getting? Okay? এই তিনটা observation বোঝা গেল প্রত্যেকে? Everyone? ঠিক আছে? So তাহলে দেখা যাচ্ছে যে আমরা আচ্ছা এটাই এই যে সামেশনটা ইনফাইনাইট সামেশন না ফাইনাইট সামেশন? Fourier series, infinite Fourier series, the finite Fourier series.
Finite.
Finite. We have added 4 terms actually. The fundamental, the third harmonic, fifth harmonic, seventh harmonic. Say. So it's a finite. So we can say it's a truncated Fourier series. Okay. We can add even the 9th harmonic. Then also it will be truncated. Then the next term will be the 11th harmonic. Then that will be the 13th harmonic. It's something like that. So wherever we will stop the addition, the summation will become a finite summation. That means what I say, it is a truncated Fourier series. I mean already এই কথাটা বলেছি এর আগে, truncated Fourier, because practically এটা possible না যে infinite number of terms add করা. So now irrespective of then this observation, we have seen that irrespective of how many terms you take, irrespective of how many terms you take means what I'm trying to say, in this summation, what this k equals to minus n to plus n, I mean number of values, n, irrespective of the values of n I'm talking in this summation, the series always converges to the middle. Look at this, from where it is passing, middle point, which is half in this example, because 1 0 divided by 2, that is half. So which is half. So always passing through this point, which is half. That means at the middle point. At the middle point. Okay. And in the other points, if you just forget about the discontinuous point, the other points, there is an overshoot and undershoot. That is an oscillation. And if you keep on adding the term, that means if you increase the number of terms, that means n, the value of n, what would happen? These oscillations, the number of oscillations will gradually die down in this cases, in this region. It will die down. Things should look like something like this. Suppose if it is a blue colored signal, this one, I'm only showing one pulse. Okay. And suppose you have added, suppose say 90 terms or 100 terms you have added. So the thing may look like something like this. This is the middle point. Like this. Okay, so it is passing through the middle point, this to C. And look at the area under this overshoot. The area under this overshoot, because I have already discussed that even though at this point, this summation and this original signal xt, they are not same, because there is a difference, because it is the overshoot, it is the undershoot, so the values they are different. But the area within this error signal is so small that means it almost tends to 0. That means in that sense you can say also it converges. Also here this overshoot and undershoot, both the area confined within that are actually reducing and as we're increasing the terms, and at this middle point almost the oscillation vanishes. It is so small, oscillation amplitude of oscillation is so small that it actually vanishes. It actually vanishes almost as if there is no oscillation, and that is happening here. So that is the picture you can get. Now here in this context I want to mention a story again. Actually you all are aware of the American physicist, you have already heard, Albert Michelson. You know the Michelson-Morley experiment, the interferometer and all those things you have already learned. So actually Michelson constructed a harmonic analyzer. The year was, I suppose, 1898 or something like that. So he constructed a harmonic analyzer. And harmonic analyzer, you all know that basically it device actually that at any periodic signal xt, suppose you give, and it will compute the truncated Fourier series, approximate something like that. That means here this summation actually it does, and it can approximate any periodic function in field or something like that. So there the analyzer he developed, there was only 80 terms. That was the limit at that time. The analyzer that can add up to n equals to 80. That is up to 80 terms that could add. Now Michelson actually what he did, he tested this device on many functions. There were different types of periodic function he generated and he fed. And he expected the result, this truncated Fourier series, okay, the x and t, this summation, this finite summation I'm talking, almost look like an xt, That means the blue color and the red color thing almost matches, very, very similar. But he faces a problem, actually he faced a problem while he tried to approximate or represent this kind of square wave, and that surprised him a lot. What he found that after using a certain number of terms, n equals to the maximum capacity was 80. After a certain number of terms, what he found that there is always a kind of this kind of overshoot and undershoot at the vicinity of this discontinuity. And irrespective of this number of ends, actually that overshoot and undershoot is sufficiently large. That means its height is not changing, its position is changing. It is getting shifted to the left hand side, to overshoot from the left hand side to this, and the overshoot from the right hand side to this point. It is shifting, but the height is remaining same. It is almost irrespective of the addition of terms, that is number of ends. Yes, it is also true the area under this is also reducing or diminishing. That's all are fine, but the height is not reducing. That's the last point I already discussed here. There was a sufficient number of terms you have added, but you are still getting some height. This is not reducing, which actually surprised him a lot. Now, what Michelson did, even though he himself was such a great physicist, but he actually, reported this thing to his friend at that time. He thought there might be some defect in his instrument, in his analyzer which he developed. There might be some defects, some instrumental problem, technical problem maybe there. And that is why he actually reported or wrote a letter to his friend at that time, who was also a very famous mathematical physicist. He was also a very mathematical physicist. He was also a physicist, but the mathematical physicist, that means the mathematical concept was very clear, very good for him. So his name is, he's a very famous, his name is Gibbs, Gibbs, Josiah Gibbs. And Michelson requested him, that he was his friend. So he requested that you please look into the thing. Why it is happening? I am expecting that there might be some missed error or some defects in my instrument. And this is particularly happening for such kind of functions which are discontinuous in nature. And that is happening at the vicinity of the discontinuity. This is the few observations he made, and this is total data, the problem. So Gibbs, this person, this mathematical physicist, Josiah Gibbs, he basically invested this problem. He took this as a challenge, and he invested for considerable and almost considerable time, but means 1 year almost. So after 1 year, he came up with the explanation, and he explained everything, and that was kind of published, in a journal, and become famously known nowadays, Gibbs phenomenon. Gibbs phenomenon. Though it was first observed by Michelson, but popularity was gained by Gibbs. It's known as a Gibbs phenomenon. Now, what is that? This phenomenon, whatever I have discussed so far, is actually this kind of oscillatory natures, etc. All these things comes under the Gibbs phenomenon. Here, Gibbs told that if the n is larger, if you increase the value of n larger, if you just keep on increasing or adding the terms one after another, if you just increase the value of n, this truncated series, this is after all a truncated Fourier series, it's a finite summation. You are increasing the value of n, but still it is finite. Please note that. So it's a truncated Fourier series. This actually exhibits this oscillatory nature. This overshoot, undershoot, overshoot, undershoot. Okay, at the vicinity of this discontinuity. This will show. He told. Okay, it will show. And not only that, he also calculated, as Michelson observed, this peak height, this height is not changing. Irrespective of the addition of terms you are adding, this height is, so the area is changing, its position is changing, but still the height is not changing. So he told, yes, the height will not change as such. It is approximately 9% of this height, more, and 9% less from this, in this direction. So if it is 1, what will be the value of this? This is the first, it is the peak of the oscillation. Look at this. among all the oscillations, this is the peak oscillation. Okay, or you can say the maxima. So this is the peak oscillation, and that occurs whether in this side or that side, at the maxima or minima, whatever you say. So the peak oscillation that occurs at the vicinity of this discontinuity. And he determined the value of this, which is kind of unchanged, remain unchanged with the addition of terms. And that value is the 9% of the actual, the highest value or the lowest value of the signal, original signal at the point of vicinity, or about the point of vicinity. So what is that 9? If it is 1, suppose, if the blue signal has a value of 1, the highest value is 1, then what will be the highest peak of oscillation? The value of the highest peak of oscillation. The 90% of that. Sorry, 90%. I'm sorry, 9% of that. The 9%
1.09
1.09. Very good. Short question আছে ঠিক আছে MCQ এরকম একটা ভ্যালু দিয়ে দেওয়া হবে আরবিট্রারি দিয়ে বলা হবে গিবস ফেনোমেনাতে বা দ্য ভিসিনিটি অফ ইয়েতে অসিলেশনের পিক ভ্যালুটা কত হবে এইভাবে বলা হবে ঠিক আছে বা ওইভাবে আসতে পারে 9%, 0.9%, 90%, সামথিং লাইক দ্যাট কোনটা ট্রু MCQ ঠিক আছে এই বলে দিলাম কিন্তু এই কনটেক্সট So, তাহলে দেখা যাচ্ছে যে regardless of the value of n, this overshoot remains almost at 9% to its peak. এবং similarly এখানে যদি 0 হয় তার রেসপেক্টে 9% মানে কত বিয়োগ করবে দেখি এটা বলো দেখি মিনিমাম কত হবে বলো দেখি
The 91%.
minus 0.09
হ্যাঁ if the lowest value is 0, this point, then what will be the value of this peak?
minus 0.09
Very good. Minus 0.09. Very good. একদম কারেক্ট ঠিক আছে তাহলে এটা যেন পরীক্ষায় যেন পারো আমি সবাই দেখি এটা যদি আসে আমি যেন দেখি না কেউ ভুল করেছো এই ক্লাসে যেমন সুন্দরভাবে বললে পরীক্ষা ঠিক সেইভাবে বললে যেভাবেই আসুক না কেন প্রশ্নটা ওকে যাই হোক সো দিস ইজ কল গিবস ফেনোমেনন ঠিক আছে আমি আর লিখছি না তোমরা জাস্ট লিখে নাও এটা হচ্ছে গিবস ফেনোমেনন ঠিক আছে গিবস এটা প্রথম এক্সপ্লেন করেছিলেন বলে এই পুরো জিনিসটা এটা হচ্ছে গিবস ফেনোমেনন এবার একটা জিনিস দেখো যেটা এখনই তোমাদের অ্যাটেনশন ড্র করলাম যে জায়গাটা এটা হচ্ছে যে বেসিক্যালি what we observe that as the number actually as you are increasing the n that means actually increasing the number of oscillations of the synthesized signal from here we have already learned that just by observing this we have learned that so n means here it's the 5th term it's the 7th term so number of oscillations is 7 here it is 9th term number of oscillations are 9 something like that sorry it is 7th or it is 5th it is 7th so as you are adding more terms that means as you are increasing the value of n actually that means the frequency of oscillation of the synthesized signal you are increasing but the width we have also observed that width of this spike of this overshoot or the undershoot whatever you say is 9%. Okay, now the point is you just see that actually within a single period if you just see then obviously the width of this spike as the width of this spike is decreasing with the increase in the number of terms or with the increase in the value of n so the width of this spike become 1 by 2n width of this spike whether this or this at the vicinity that is 90% overshoot or undershoot okay now as n increases just you see as n increases so if this term decreases so this is actually the width of the spike is spike and width the width of the spike so this actually width reduces as n increases the number of terms you are increasing in this series in this summation that means you are adding more terms more high frequency terms the high frequency means more oscillations means less is the value of the width of this spikes and overshoot and undershoot spikes so that means in that sense you can say as if the spikes the area under the spike is kind of diminishing kind of becoming zero then as n approaches infinity, at least mathematically, then this energy, error energy, actually tends to zero. Because error আসছে কোত্থেকে? Error is coming due to this, এই যে এর মধ্যে যে এরিয়াটা থাকছে সেখান থেকে তো এররটা আসছে। And that is actually the width যত widthটা বেশি হবে এররটা বেশি হবে। So width is actually closing, becoming smaller and smaller, squeezing, narrow down হয়ে যাচ্ছে the spike গুলো। তার মানে width যত tends to 0 হচ্ছে, তোমার এরর তত 0 হচ্ছে। So এভাবে আমরা বলতে পারি যে the statement we can make that as n tends to infinity, that means as you are increasing the number of terms in the summation or in the series, as that means more number of oscillation, more high frequency terms you are adding, the number of oscillations you are increasing, the corresponding Fourier series may differ from ft, that means Fourier series summation may differ from ft by about 9% at the immediate left and immediate right, that is at the vicinity, immediate left and immediate right at the point of discontinuity, and yet the error in the energy tends to 0. That is all about this Gibbs phenomenon. And this is not only true in case of signals, wherever in our life, in reality also, wherever there is a point of discontinuity and we try to approximate, you will learn in the filter, when you design the filter, always remember this Gibbs phenomenon. In the DSP, digital signal processing, when you will learn or read the chapter of filter design, there you will actually encounter this property, this particular phenomenon, Gibbs phenomenon. Wherever you will try to represent or approximate or reconstruct a discontinuous thing, there will be an oscillation at the vicinity of that. Or whenever you will try to make something discontinuous, there will be some oscillation, some vibrations. And that's the matter of fact. That is true in all senses, not only in the context of signal sense system. I'm giving an example. Possibly you all have, I don't know whether you prefer veg or non-veg, or I don't know, but anyway, irrespective of that, a choice or your preference, have you ever went to the butcher shop to buy meat or something?
Yes, sir.
Okay. There you have seen, I'm not going into the details, but whatever, probably you can understand what I'm trying to say. So when the animal is beheaded, that's the head and its leg is basically separated from his body, okay, there is a vibration. It actually vibrates. The body, the rest of the part actually vibrates, and vibration mainly happens at that point of discontinuity where the organ is separated from the original body or the actual body. So if you cut the head, if you cut the leg, there's a 2 point of discontinuity, that discontinuous point, and that is a vibration. It keeps on vibrating and gradually it dies down, and that's it. So it's the analogy. As I mentioned, in every case, you will see that whenever there is this kind of discontinuity, if you want to make anything discontinuous, sharp discontinuity, there will be, it is settling down is very difficult. The meaning is that settling down is very difficult. Anyway, so আজকে এই অবধি থাক, ফুরিয়ার সিরিজ আমার কমপ্লিট। আচ্ছা, এবার যেটা বাকি থাকলো সেটা হচ্ছে শুধু ফুরিয়ার ট্রান্সফর্ম। সো ফুরিয়ার ট্রান্সফর্মের জন্য আমরা কালকে একটা ক্লাস নিয়ে নিই, ঠিক আছে? কালকে কটা থেকে করতে চাও বলো?
মানডে হলে প্রবলেম হবে?
আমার কোনো প্রবলেম নেই, মানডে করো তাহলে। আমি তো তাড়াতাড়ি শেষ করতে চাইছি তোমাদের, দেখো তোমাদেরকে ফ্রি করে দিই মানডে। আচ্ছা, মানডে কখন করতে চাও?
সকালের দিকে 10টা থেকে।
ঠিক আছে, মানডে তাহলে 10টা থেকে, ঠিক আছে? তাহলে আমি আর মেল করছি না সেপারেট, আমি জাস্ট এখানে ডিসকাশন হয়ে গেল। ওকে, মানডে মানে হচ্ছে কত তারিখ? 17, তাই তো? 17, ওকে, 17 সকাল 10টা থেকে, ঠিক আছে। আচ্ছা, একটু কানেক্টেড থাকো, আমি অ্যাটেন্ডেন্সটা আজকে যে পার্টগুলো পড়ালাম সেখান থেকে প্রচুর প্রশ্ন আসে, প্রচুর। এমসিকিউ বা শর্ট টাইপ কোশ্চেন তো মানে প্রচুর প্রচুর আসছে। আচ্ছা, 303 অ্যাবসেন্ট, 306 অ্যাবসেন্ট, 308,
Present, sir.
309,
Present, sir.
310,
Present, sir.
311,
Present, sir.
313, 315, 316, sorry, 316,
Present, sir.
318, 319, 320 नहीं, 321, 322,
Present, sir.
23, 4,
Yes, sir.
5,
Present, sir.
আচ্ছা 3 ইয়ার্স এর হলো, কেউ বাকি আছো?
স্যার 303 দিয়েছেন?
303,
হ্যাঁ 303 আছি স্যার।
ও আচ্ছা, আমি বুঝতে পারিনি, দিয়ে দিলাম, ঠিক আছে।
হ্যাঁ হ্যাঁ
আর কেউ,
বলছি আমার কানেক্টিভিটির জন্য হচ্ছিল।
আর কেউ বাদ গেল? 303 তো দিয়ে দিয়েছি। আর কেউ আছো 3 ইয়ার্স এ? আচ্ছা, এবারে তাহলে 4 ইয়ার্স এ যাচ্ছি। 4 ইয়ার্স এ 401,
Present, sir.
6 absent, 8,
Present, sir.
406 আছে, মাইকটা প্রবাবলি কাজ করছে না।
আচ্ছা আছে, ঠিক আছে, দিয়ে দিলাম। ওকে, 411,
Present, sir.
416, 416 absent, 418,
Present, sir.
418, 419,
Yes, sir.
420,
Present, sir.
425,
Present, sir.
427, 428, 429,
Present, sir.
স্যার
430
428 ও প্রেজেন্ট আছে।
428 প্রেজেন্ট আছে। আচ্ছা ঠিক আছে দিয়ে দিচ্ছি। 428 প্রেজেন্ট, 429 প্রেজেন্ট, 430,
Present, sir.
431,
প্রেজেন্ট স্যার।
2, 432,
Present, sir. Present, sir.
ওকে। আচ্ছা, তারপরে কত আছো? 433 আছো কি? 433 নেই, 435, 436, 437, 438, কেউ 4 ইয়ার্স এ বাদ গেলে কি? কাউকে মিস করলাম? ঠিক আছে তাহলে মানডে, ঠিক আছে, 10টা থেকে।
হ্যাঁ স্যার।
ওকে।